What's going on, guys? It is Brandon for Brandon's Show. It's Wednesday, January 13th, 2021. Hope everybody is doing good out there. I'm doing pretty good. And no, Paige, it was not the cat that made me late. Pretty close, but not the cat this time. Give me a thumbs up if you can hear me okay. Everything tells me that you can, but just to be sure. We got some cool stuff planned for tonight. There was going to be a debate between Bab Space Pope and Paige. It looks like that may be falling through at the last minute, but we'll figure out what to talk about. I'm sure there is plenty to discuss. Actually, one thing did fall through for sure, which is that George isn't going to be coming in to talk about the K value and refraction. So pretty much everything I had planned for tonight fell through late. So we'll see. I'm sure I can dig through my bag of tricks and maybe we'll just bullshit for 3 hours. That sounds good. Okay, let's see who we got in chat. Page 42. I see the thumbs up, guys. Thank you very much. Dank, SE Montreal, Ian Adams, Chrissy Heavey, Gary Whitebenga, Alexander Lightwater, Tay Boo, Mobius Maximus, Jack653, A Snowman, and Matrix Media, who was first, although Ian Adams claimed first. What's going on, guys? Hope everybody's good out there tonight. Let's see here. We've got some people in the Discord chat. But before we get to that, let me give the link out to support the show through Streamlabs. If you like the show and want to support it, you can do so through Streamlabs or Super Chat. The best way you can support the show is to come in and talk to us, bring us some new information, show us some scientific evidence of the shape of the Earth, which I personally believe is flat or a flat plane. And I'm proud to say it. But there's a lot of people who disagree with that. And I'm sure we'll hear from some of them tonight. And we'll see if tonight's the night that they bring some scientific evidence. Maybe a practical demonstration would be nice, not relying on, oh, it's a couple hundred years old. We've known for thousands of years. Or, yeah, if you hang this weight on a rope and swing it around, you can tell that the Earth's rotating. Give us something good. Give us something meaty that we can dig into that doesn't rely on presuppositions and assumptions and that can't be validated. You know, give us some information, please. Otherwise, it just feels like we're in a religion, which is not a bad thing, but, you know, that's not how it's sold. Okay, let's go into Discord and see what's going on in there. What's up, guys?
What up?
Hey.
Got the
Sphere or be sphere.
real Fonzie there tonight. What's up, Travis? How you doing, man?
Oh, I was trying to be Fat Albert.
Oh, duh, yeah, Fat Albert. Yep. Mixed up my 70s sitcom characters. We got Carlos Pagan. What's up, man?
Not much. Listening in.
Okay.
I think that's Carlos Pagan. Pagan. He's a pagan. Am I? Is that your conspiracy theory?
Is it pagan or pagan?
It's pagan.
See, I was closer. I don't know. There's some sound in there that
it would be.
We don't use in English. I think
it would be the equivalent of pagan in English. Yeah.
Okay, gotcha. Cool, man.
But it is a last name, not my religion.
Understood. Yeah, and I'm aware you have discussed how you're a Christian many times. Cool, man. And Jeremy, what's up, Jeremy?
What's up? How we doing?
Not bad. You still out there just screaming, how do we make a straight line? Help me make a straight line.
For real, man.
I know. How hard can it be to make a fucking straight line?
A plumb.
Gentlemen.
We'll get into it in the show.
We will. What's up,
There
Jimbo?
is a search. Again, hello, everybody. I'm going into a police planet tomorrow. We got a lockdown. We're not supposed to leave our homes. but that's beside the point. There is a Searchlight. It's 150 pounds. It's a military marine Searchlight that has a beam, a visible beam, 7 miles.
What?
Yes.
That's a long way for a frickin' searchlight
Well,
beam.
it's intended to blind pirates on the ocean miles away. And it does.
This is the U.S. Navy, you said?
No, anyone can buy one. They sell them here in Canada, U.S. The Carlyle Group sells them basically. But I'll try to find it again and post it. Now, mind you, it comes with a $2,500 price tag.
Okay.
But it has a 7-mile beam.
When you say a beam, you mean it's like collimated or what?
Yeah, you can see the light ray focus pointed 7 miles away. The whole beam is long. So
What
let
do you mean
me.
you can see it focused and pointed?
Yeah,
Like,
I got my little handheld one, and I'm happy with that. I get my light seen 25 miles away.
Yeah, your little
But
$10
this one
laser that
probably do a
is
little better.
amazingly bright.
Yeah, I got a bunch of green lasers, do 50 miles, no problem. No problem. But again, like I say, on days when, like now, there's a lot of humidity in the air, even that laser doesn't make a beam. It makes a big old cone.
Oh, yeah, sure. Yeah, it spreads out. Yeah.
Dramatic difference. Dramatic. Even the beam flashlight I have, with this humidity and droplets in the air, it forms a real big cone instead of a beam.
Huh.
Still has a beam portion, but it cones out. Absolutely.
That's interesting.
So
Yeah.
that's the white light and the laser. So, but in any case, I'll hunt down this 7-mile beam, blinding freaking light that the military uses to control pirates.
Hell yeah.
And
Show
do
us the
other-
pirate light, man.
So let me find it there.
Okay.
Maybe a bunch of people can get it to shine across the English Channel or something to France. God knows what. It'll make it.
I'm sure we can figure something out to do with that thing. Let's see who else we got. Space Pope Babs. What's up, man? You there? He's on mute. Anyway, what's up, Babs? I heard you got an experiment for us, so we'll talk to you about that when you are able to talk, or you got something to show us. That sounds pretty cool. So I was just saying to the audience before the show that the debate fell through between Paige and Babs. Last minute kind of thing. And also George backed out of presenting his K value, how you quantify refraction when you're surveying, which I was really interested in hearing about, but whatever.
Well, apparently when they're surveying, they only need to have the measurements at 2 spots. When you're making a horizontal line like the main surveyor did with the plumb lines aren't parallel thing, he took the refractive measurement, humidity, temperature, pressure at point A, then took the same measurements at point B, and somehow came up with what's happening in the middle. I don't know how they got that, but it's interesting.
Yeah. Yeah, I got a good example for you guys of the kind of shit that we have to put up with these trolls in Discord. And I'm sure you guys see this crap everywhere too. Let me share my screen in the Discord. All right, there we go. If you can see the moon from here during the day, then you can also see the sun from here. What? I don't think we see the moon when it's over there. When it's light over here. Right? What else are they talking about? Even on the globe, you don't see the moon when it's on the other side of the earth during the daylight. You see it when it's in the daylight. Am I missing something here? You guys see this?
My bad. What are we looking at your stream here?
Yeah. Yeah, this very, very lame meme.
Well, the problem is they think light travels forever. They don't know about the attenuation of light or, perspective or anything. And I think they have refraction wrong. But anyways.
Yeah, right. They have the assumption that the sun's light travels millions and millions and billions of miles, millions of light years, whatever. But even on the globe, okay, let's say turn this flat plane, which is a straw man flat plane that is more like a symbol than what we actually think, in my opinion. Turn it into a globe. You've got the moon on this side, right? And you've got the sun on this side. When that happens, you don't see the moon. The fuck is he talking about?
Yeah, if the moon's over South America and the sun's over what appears to be like Australia or something, you're not going to see them on the globe either. I don't know.
Right.
That model that we're looking at right now, when the Earth, you see the sun. Sometimes it'll be a GIF with the sun and the moon moving around. That model is it's a reification fallacy, but that for new flat earthers coming into it, that helps you get a grasp on how to visualize what's going on. You know what I mean?
Right. Yeah, absolutely. Because when you first hear about flat Earth, you're like, what? How could it be flat? The sun and the moon are up there, and circumnavigation, and you learn all that like day one shit, right? So it does help you visualize it in your mind and describe it to people how it would look, how it might look. But obviously we don't have a flushed out map or model, in my opinion. Some people do
absolutely
think that AE map is accurate. I don't. But who knows? Yeah, so this is nonsense anyway, Flurfer Nerfer. Has anyone ever seen the sun in the dead of night? Thought not. LOL. Flat Earth debunked.
That's cute.
I mean, it's just it's absolute stupid comments like that either you just know that you can't take them seriously, but then they're wasting your time, or they're legitimately stupid. Because those are the only two options. Either you really don't get it, and it's very simple, or you are just freaking wasting time.
I think it's a wasting time thing. Like we were looking at that spreadsheet yesterday, just kind of throw as much shit at you, waste your time so you can't do any real research and fuck with you. But yeah, maybe some of them are stupid. I don't know, Flurfer Nerfer, are you stupid or are you a time waster? Help us figure that out. We've got some evidence here. We don't know how to interpret it. Anyway, so what's going on? What's new in the world of the plain truth, man?
Me and Essie and Rocky were killing him in Jose's earlier. I don't know.
I think I heard
I felt
some
like
of that.
I felt like one guy was using that script that you showed last night.
What gave you that impression?
I don't know. He was asking, how do earthquakes happen on a flat Earth? And I was like, I don't know. And then, I don't know. It just felt like he was running that script of always wanting to be the one to ask the questions. And, how does this work? How does that work on a flat Earth? Like, we don't have all the answers.
Right.
We don't know.
Right. Yeah, and they hold that against you. You don't have all the answers. What, you want me to leave my model? You want me to stop using my model? You want the whole world to adopt flat Earth, and you can't even tell me, you can't even give me an accurate layout of the entire Earth? Like, no, who asked you to, throw your model out? Who asked you to get rid of your math? Who asked you to do anything? You don't have to do shit. I don't care what you do.
Check. Can you hear me now?
Hey, what's up,
What
Babs?
up, Babs?
How's it going, man?
Not bad. Yeah, carry on. I just wanted to ask for 10 minutes to show you something when we get an opening.
Okay, cool. Yeah, I saw that you had some kind of something to present. That's cool.
Yeah.
And we had the real Bob Dole join us too. What's up, Bob?
Hello.
Actually, now's not a bad time. We're just bullshitting if you're ready, Babs.
Just
I
to say,
posted a link to the 7 Mile
Bob was
beam
low
searchlight.
for me.
I was low for you?
That's a little bit better, but yeah, you were very muted.
Here, like, I can adjust my mic closer. Does that sound better?
That's better. Yeah, that's better.
Oh, okay.
Yeah,
Just
actually,
give
your
me a
mic is
second,
real low
Brandon.
usually, Bob. I have you turned all the way up in Discord. But
Bob is always a bit
Really?
low.
I didn't know that.
I put the link to a demonstration of the 7 Mile searchlight.
Okay, well, we'll talk about that in a minute. Let's if Babs is ready, we'll see his presentation and then we'll go to that stuff, Jimbo.
Just give me a minute. I gotta put this
Oh,
stuff
no.
together, and I'll let you know when I'm ready. And yeah, just give me a minute.
Okay, all right, that works out then. We'll just take a look at this. So this is the search.
So just real quick on.
Oh, go ahead, Travis.
Yeah, just real quick. I was just going to say that could possibly work for vertical demonstrations as well. If you've got a long enough distance between them, you could shine them up 90 degrees and see that they don't deviate from parallel.
Oh boy, how far would you have to have them apart to see any measurable...
Right. Well, that's right. Well, but that's part of what I'm saying is that again, our argument is if you've got curvature on the y-axis, you're going to have it in the x-axis, so it's going to be both ways. So it doesn't really matter. So I the only thing that the Verrazano Bridge in the stuff that I looked at, they don't have any documentation on how they know that the top spires are 1/8 of an inch apart. The only way they can know that is by math.
Yeah, they try to do the same thing. Oh, sorry. Go ahead.
That's okay. But, they'll say where they're posted, they're 90 degrees straight up, but they're so far apart from each other that there's 1/8 of an inch angle. There's 1/8, whatever the degree of angle would be for that. Anyway, but if you go out to the salt flats, and if you can get 10 miles away from each other, that's going to be, I don't know, 15 miles away, whatever. But also, how far away would you have to be able to see the light? Because it's got 7 miles of distance, but that's horizontal. So if you shine it up straight up and down, can you still see it 7 miles away? I don't know. I was just thinking. That's all.
Yeah, no, that's an interesting idea. Somebody else I saw had an idea like that too, where if you look for left and right to right curvature from a distance. The only thing with that is, then again, you're into optics.
Yeah.
Might be interesting though.
We have tons of observations where we see too far. So.
Yeah, that we do. No shortage of that for sure.
Did you get my DM?
Oh, let me take a look. Yes. Got it. Okay, you want me to bring this up?
Yeah.
Cool.
How do I get a fancy color for my name like Paige has?
So that's for
And Space Pope.
the debate room, because they were going to debate. So I guess the answer is if you can set up a one-on-one debate with someone, then you will get the fancy color.
What if I heavily develop a second personality to debate against, and then I can debate myself one-on-one?
It might be interesting to listen to. So yeah, if you could give us a sample of that. I'm down to try anything. I'm having a little trouble opening it. Let me see what I can do here. Oh, I see it's downloading. Okay.
You got something good for us, Babs?
Yeah, I got that good shit for you.
No doubt.
Where is it? Open up. Come on. Document could not be opened. It isn't compatible with QuickTime Player.
Do you have VLC?
I do, yeah.
Try open
Yeah.
it with VLC.
All right, let me see if I can do that. Open. All right, hold on here. You can't open it. You can't share your desktop or what?
It's too risky.
Too risky. Okay.
Bad.
Yeah, I got X Hamster, Pornhub, all types of shit on here. So no.
Yeah. You know, it's too difficult to make sure all your tentacle porn tabs are closed, right?
Right.
All right, it's doing something. Let's see what it does. Here, can you see that, Babs? So I opened it in VLC.
Hang on.
Okay.
It's not letting me
VLC would like access. Oh yeah, okay. There we go. We got it, man.
Yeah, there you go. Yeah.
Cool. Sorry for that, folks. I know that's totally interesting listening to my technical issues.
So yeah, if you remember what we were talking about last time was what is the cause of atmospheric pressure? And my argument was that gas pressure is different from atmospheric pressure. In the example of gas pressure is the result of gases bouncing off of the walls of a container, whereas atmospheric pressure is the result of gravity. So how do we prove this, right? With an experiment. We've seen it done before, but a lot of you guys aren't willing to accept that. Like if I was to take a gas and pour it into a container and weigh that gas, they're going to say that it's in a container still, right? So we had to take it to a whole different level where we poured the gas directly onto the scale. No containers were involved. The only container was the one where the gas was stored temporarily before it was weighed. So if you can see from the setup that I have right here, the gas that I manufactured was carbon dioxide. And to make carbon dioxide, all you need is baking soda and vinegar. So when you mix those two together, you end up with this mixture, which is a liquid, and the gas sort of collects above that mixture. So what I did was I got a measuring jug, I mixed in the vinegar with baking soda, and I covered it up with some tinfoil. I gave it some time for the gas to collect in the measuring jug. Then what I did after that is I got a really sensitive trail, and I started pouring that gas very slowly onto the scale. And as you can see, the scale measures a 0.2, close to 0.3 gram reading of gas. So the only way that would be possible was if the gas was moving in a downward vector. And as we know, gases are subject to diffusion. So the gas is not going to settle above the scale indefinitely. It's obviously going to diffuse into the available volume. But that's different. That's gas moving from a higher concentration into a lower concentration. That has nothing to do with gas diffusing into a vacuum. So the point that I'm trying to demonstrate here is that gases have mass, gases have weight. And we've seen that in the past where if you take a balloon and you weigh that balloon on a scale, then you add helium to that balloon, then you weigh it again, you notice a weight difference. And the only way that would be possible is if you're injecting mass into that balloon. So anything that has mass has weight, and anything that has weight exerts pressure. And we know that the atmosphere or atmospheric pressure is the result of the gases in the atmosphere. We measure that using mercury barometers or whatever barometers. I can't remember the name of the other type of barometer. But yeah, we can measure the weight of the atmosphere using those tools. So that there is enough evidence to tell you that it's not a container that's causing the gas pressure the gas pressure in the atmosphere. It's the result of the weight of the gases in the atmosphere. And as we discussed before, there's another issue that comes up with this whole density thing. We know that within the troposphere, the atmosphere is homogeneous, meaning that it is a mixture of specific gases. And that mixture isn't stratified. There's no stratification within the troposphere. By stratification, what I mean is that the gases aren't separated based on their densities. It's all an even mixture. And the only thing that's different is that at sea level, the gases are more concentrated. Because at sea level, closest to the ground, the force of gravity is strongest. So obviously, you're going to have more particles at sea level. And the higher up you go, that force starts to get weaker and weaker. That's why the particles reduce. The amount of concentration of these gases is less because there's less force acting upon them until you get to a lower pressure system. Now, that doesn't mean that space exists or the idea of planets, as has been described to us, is a reality. It just means that we can't be under a container just based on that premise. And another issue is that, I did talk about stratification. Another issue with the density thing is I'm going to have to show you an image to illustrate this point. Just give me a sec. I'm going to upload it to the Discord. Oh, I'm just going to send you a direct DM. There you go. Did you get it?
Yeah, got it now.
You got it? Okay. I'm just going to wait for you to put it up on screen.
Babs, the video with the scale when you were pouring the CO2 out, that was pretty low. The lighting was pretty low in there. Do you have one where it's lighter, where we can see better? Or?
I probably could. I did this in my basement. It's pretty dark down here, but this is where I do all my my science shit. I could probably do it in my kitchen upstairs with like better lighting and everything. Oh, but yeah, I'm gonna try to do a better video than this. So the issue that I find with this whole relative density thing, it makes sense, but only to a certain level, right? I'm just waiting for the thing to come up on screen so you can see exactly what I'm talking about.
Yeah, it's not opening.
It's not opening?
Mm-mm.
Oh man.
Yeah, I don't know.
Bad. Was it a JPEG?
No, it's a WebP.
Oh, that's why. Damn it.
I can I'll drag it over. I mean, it's not going to be big though. That's the only thing.
Hang on.
Okay.
I think I might be able to give you a better one. Oh God.
Babs, what we observe though is heavier objects more dense objects in the medium they're in, they go down, and less dense objects in the medium they're in go up. That's what we observe, right?
Yeah, we observe that. Yeah, we do. But that only applies to specific things, though. Like if we're talking about solids and liquids, yeah. But gases, like the atmosphere, the troposphere is not stratified. There's no stratification. The gases are all mixed together uniformly. The only thing that's different is the concentration. So yeah, Brandon has an image on screen here. So as you can see, there are these two objects, and they both have the same density. They both have the same mass per unit of volume. And that's all that density is, mass over volume. So what we do notice, though, is that when we take two objects that have the same density, same mass per unit of volume, but then we alter the volume of one of those objects, we start to notice that the larger object exerts more force than the smaller one. Now, logically, it makes sense because you've added mass. You've increased the volume of one, so it's obviously going to be heavier, right? But then you haven't changed the density. They're both still the same mass per unit of volume. The only thing that's changed is the amount of matter. So that there tells you that there's more than one variable at play. It's not just relative density. There's relative density and there's also weight that causes things to move in the downward vector.
But I think we're mixing different things up when we talk about this, because this came up last time, and
Yeah.
I wouldn't expect two equally dense, different sized objects to weigh each other out. I don't think the weight is a function of their density. I think it's a function of how much mass they are. What the density decides is how that matter is going to orient itself within the medium that it's in.
Right, and that's relative density.
Right.
Relative density is how objects that are made of matter orient themselves in relationship to the medium that they're in. But that is a function of gravity. Without gravity, that wouldn't be possible. Also,
Talking about,
go ahead.
my bad, go ahead. But were you talking about mass attracting mass or space-time bending?
No, that's not what we're talking about right now. We're talking about the factors that contribute to the downward vector. One of them being relative density, another one being weight.
So you're when you keep talking about a force, you just, I think Jeremy's question is the same as mine. You're just saying there is a force. It doesn't sound like you're naming a cause of it, which is really the problem.
I did name the cause.
Okay.
I may not have gone into the cause today, but I did name it the last time I was here. Mass
attracting mass. Yeah, see, that's where I have the problem. I don't know how you're crossing that bridge.
Which part of this shows that the relative density isn't enough?
Which part of this shows that the relative density is not enough?
Right, for it to determine its direction up or down. Because that's your point, right? You're trying to make the point that it can't be just relative density, right?
Yeah, the point is that when we're performing a scientific experiment, we look at a multitude of we look at a multitude of causes that could contribute to the overall effect that we're observing. So we can't rule out weight as being one of the causes, and this particular setup demonstrates that. It demonstrates that weight is a factor in that equation.
Right, I'm asking you which part demonstrates that weight must be a factor. That's what I want to know.
The part that when we have two objects of the same density, when we increase the volume of one of those objects, we notice that the larger object exerts more force than the other object. That shows that weight is a factor in that equation, not just density.
Well, whoever proposed that things could be balanced...
Wait, hold on.
Okay.
How did you have two objects maintain the exact same density while adding volume to one and not the other?
Because density is a measure of mass per unit volume, which means the orientation of the molecules within that particular object is what defines density, whereas mass or weight is something different.
You can have an ounce of silver and then chop it into a quarter of it off, and they're both going to have the same density.
Exactly. You see, Jeremy gets it.
Yeah, but what are you getting at, though?
Yeah.
Okay. There's something wrong with that, though.
What I'm getting at is that it can't just be density that's causing the phenomenon that we call gravity. There's a multitude of factors that contribute to that.
I don't think that your demonstration
if you were to take an ounce of silver and then another ounce of silver, and you formed 1 ounce of silver into a ball, and another ounce you spread out as thin as you could possibly get it, and then dropped them both from the same height, they wouldn't fall the same, right?
Yeah, because they both don't have the same aerodynamic properties, meaning the ball has more aerodynamic properties than the flattened out piece of aluminum or steel that you were referring to, because it has a larger surface area, which creates more friction when accelerated.
Okay.
But would the claim still be that both of those items, 1 ounce of silver in a ball and 1 ounce of silver flattened out as much as it could be, that they both have the same density?
Yeah, they both have the same mass per unit of volume.
Babs, if you think weight is, are you done, Bob, or did you want to keep going?
I'll come back to it if I want to continue.
All right, Babs, you think weight is a factor on it then?
Yeah.
All right, I'm going to take 10 pounds of helium and put it into a giant fucking balloon, right?
Right.
It's not going down.
No, it's not, because of buoyancy.
Because of relative density.
Yeah.
The thing that we're arguing for and telling you this is what it is.
Well, that's the thing, Jeremy. I'm not denying that relative density is a thing. I'm just saying that it's not the only thing that's happening.
But if weight is a factor, why is the balloon going up and not down? Because of the thing we're saying.
Because helium is less dense than the surrounding atmosphere. So it's obviously going to rise higher up.
So
I know that's our argument, though.
How many pounds of helium? How big does the balloon have to be? How many pounds of helium or how many tons of helium before the balloon will go down?
I can't answer that because I haven't done that experiment yet.
It'll never go down. That's the answer.
Because helium is never going to be.
Aren't we still talking about mass, right? With the gases that we're talking about. So why does it leave the surface of the Earth to begin with?
Why does it not leave the surface of the Earth?
Why does it leave the surface of the Earth to begin with?
Oh, because of
the Earth, the mass of the gases.
Oh, because of diffusion. Because if you have gases that are occupying an area of higher concentration, those gases are generally going to diffuse into the area of lower pressure.
I know that, but isn't that an issue for this whole mass attracting mass situation, though?
Not necessarily. It's only an issue if you didn't have. Well, no, it's only an issue if you didn't have gravity to counteract that. If you didn't have gravity, then yeah, all those gases.
Where's gravity when the gas is going up? That's ultimately the question. Since mass is attracting mass, why isn't it attracted to the surface of the Earth long before it gets up there?
Because the force of gravity is strongest at sea level. So obviously the gases that are at higher altitude are not going to be affected as much as the ones that are on the surface of the ground.
Didn't I ask how they got there, though?
How did the ones at higher altitudes get there?
Yeah, from the surface, right? How'd they get up there from down here?
By diffusion.
Okay, so I figured out what the problem was.
No, I figured out what Elijah's problem is. It's not really a problem. Let me not I wasn't talking about structured in that manner. The problem is he's wondering why the gases are not completely being eliminated from the surface of Earth, because they're constantly being produced at ground level. So you have this constant exchange happening.
I'm asking why it's going up, right? I'm not asking why, we have it. I'm asking why. Yeah, go ahead.
It's going up because of diffusion.
Okay, so let me ask a follow-up with that. So if helium is less dense, but it's produced at ground level where gravity is the strongest, how is helium sneaking past? And you just said diffusion. So are you going to stick by that?
It's not sneaking past. It's diffusing from an area of higher concentration to an area of lower concentration. I never denied that that's not happening. It is happening.
Diffusion.
My only problem is, you're saying? Well, my only problem is what is mass? It appears that mass is everything, so it doesn't give enough distinction to really guide intelligible action or intelligible exploration in science, because it seems like there's a lot of stuff that's, linked under mass. I'd probably go with electromagnetism or something that's a bit more specific for exploration, because until somebody can point to me, exactly what mass is other than a philosophy, it's just a little too general.
Right. But generally scientists don't discuss semantics. They perform experiments and discuss their data. So we can demonstrate through experimentation that things that have mass and weight exert pressure.
But if you haven't demonstrated what mass is, it's just philosophy. Because you need to show what mass is. Exactly. It's a block of mass.
Why do we need to show what mass is? Why?
Hold on,
Because
let's let
otherwise you have a questionable philosophy that's way too general to guide exploration.
Let's
Why
let
is
Babs
it a
get through.
questionable philosophy?
Well, is there a block
Ask him
of
what-
mass or what?
Ask him what mass is. Ask him what mass is.
Yeah, he doesn't know.
Yeah,
Okay,
I mean,
this
I
is-
don't know. I don't know everything. I'm not the Dalai Lama.
Well,
You
no,
showed
but
those-
okay,
I got
but
you, I
hold
got
on. Yeah, but I think that Lemon Bird is just bringing up a reasonable point, right? Which is a little bit of a reminder to me of what my point was, is that when you cross the line into metaphysics, right? So if you say mass and I say what is mass, and you say like you just did right now, well, I don't know everything, so I'm just going to put words into your mouth. I don't know what mass is. That's philosophical then. You've crossed the line into an idea. So let's go back a little bit. Can you, just in a bare bones description, what do you mean by diffusion from more to less at the surface when talking about helium? Can you just kind of unpack that a little bit?
Sure. What I meant by diffusion is the behavior that gases generally display, which is they move from areas of higher concentration to areas of lower concentration until equilibrium. And I mean, the reason that I don't particularly like the semantic arguments is because they don't really result in
This
anything.
isn't a semantic argument. You're using terms, and I'm trying to understand your term. That's not semantics. I'm asking you to define and use and explain your term. So,
Babs, if that,
Sure, no problem. Yeah, I
Okay.
understand, no problem.
Hello?
Yeah,
My
diffusion
mic
is
work?
when gases move from an area of higher concentration to lower concentration.
Does my mic
Babs,
work at
if
all?
that, we hear you, Jimbo. Babs, if that happened though, wouldn't it keep going? Why would it stop?
Because there are forces acting upon those gases.
Well,
That
check
might-
this
may I
out.
say
Check
something
that.
here?
Hold on. Check this out, right? So you're agreeing that a higher concentration of gas is going to move to a lower pressure area, right? Like, but in this case, that would be away from the Earth, right? And as far as forces go, when you're talking about mass attracting mass to the center of a body, right? The gas is doing the opposite, right? So that's a contradiction.
I don't think so. No.
I'm just trying to see how specific this is because mass has many definitions, one of which is something that takes up space. Well, for something to travel, it needs to take up space, so that would include energy too. Because for energy to travel from place to place, you think it has to take up space too. So this mass definition could potentially include everything. Is mass really something with a real essence that's definable and gives us distinction and intelligible scientific action? Or is it just a general philosophical term for something that we can see that takes up space?
Hello.
referring
May
to
I have
volume,
1
rather.
minute of interjection here in the 3 hours that's going to be going? Or do I have to elbow my way in and be like an asshole? Could I?
well,
say
you
that?
don't.
Jimbo.
Hold on. Listen, you don't have to be an asshole, but no one's heard you speak until just now. Lemonwood was talking.
Yeah.
I didn't hear you say anything until you
Well,
started
I did try
complaining.
to come in about 5 minutes ago, and then a couple of minutes ago, and what the fuck,
Go ahead, Jim. Go ahead, Jimbo.
I was just going to
what
say
happens
something.
with-
Shout out to everybody that's
We'll
trying to
use.
Uh-huh.
Oh, keep going, gadget. There, fuck.
Everybody's
now,
staying
water.
patient. It's unbelievable. It's
Would you
brilliant.
shut the fuck up for 1 minute?
Okay,
Now,
Jimbo,
water
go
when it
ahead.
evaporates. You fucking dickhead. Now, when water evaporates from a lake or whatever, it does evaporate into the air. But guess what? The air is able to hold in 1 square meter different amounts of water vapor depending on the temperature. And there's a factor called like miscibility or solubility. Now, if you take a liter of water and you pump ammonia gas into it, the volume doesn't increase, but you can put 14,000 volumes of ammonia into a liter of water and not change its dimension. Now, as far as mass goes, we set benchmarks. One of those benchmarks is standard temperature and pressure. 1 atmosphere at sea level for 1 cc of water is 1 gram. 1,000 of those, a kilo, at 72 degrees at standard temperature and pressure, is our mass. And we work from there, from a benchmark. It's not philosophy. You tell me 1,000 cc's of water is a philosophy. It's not.
But the thing is, it's a kind. It's like store. You can't point me to store. You can point me to Walmart. You can point me to a particular of that kind store, but you can't point me to store. You can point me to, Toys R Us. You can point me to a particular, but you can't point me to the kind store. It's the same thing with mass. What the hell is mass? Is there a block of mass? Can you give me a particular that really elucidates it, or does everything take up space, just like this mass definition, and become meaningless? Are we dealing with a meaningless definition here, or what?
Yo, can you guys hear me?
Let's let Babs finish. Yeah, let's let Babs finish his presentation, and then we'll tear it to shreds.
Oh, I'm actually done. I was just gonna say, I'm having some technical issues here, so I might drop in and out. I've been having computer problems all day, but yeah, if I do drop out, I apologize, guys.
That's fine.
Okay, when you talk about. Okay, I'll let you go first. That's fine.
It was real quick, Bob. It was just real quick. I just don't want to lose it. I want us to try to maybe restate what Babs has argued. Go ahead, Bob.
Okay, I was going to ask him, whenever you talk about the gas and the density, are you using the physics term density as defined in physics?
You mean the term of mass per unit of volume? Yes, that is density as defined in physics. Yeah.
Okay, do you know how to determine the volume of gas so that you can do that?
What do you mean by determine the volume of gas?
If you're going to determine how much mass there is per unit volume, you need to determine the volume of the gas to know its density.
No, not necessarily.
Okay.
You can determine the density of a gas based on the amount of pressure that gas exerts, or its kinetic.
Exactly.
Yeah.
Do you understand that to determine the amount of pressure that it gives off, you will need a container, because without it, you will not be able to determine the pressure.
That's true, but that's not the only way to measure.
Okay, so wait. I want to clarify your claim earlier that we can't be in a container is incorrect, because there's no way we could determine the density of the gas without the container, because we can't determine the pressure.
Yeah, we can. We can determine the density of the gas if we gather the gas in a container. We can measure the mass over volume.
Okay.
Which is the density.
So without the container, we cannot determine the density of the gas, like I said.
Yeah, we can, because we know that gases have...
You literally just said if we put it in a container, then we can determine the density. So without the container, you literally cannot determine the density.
Well, if you're willing to listen to all the examples I'm willing to give you, instead of just harp on for a win like you're trying to right now, instead of having a real discussion, then you'd understand.
It's not about winning. I'm not worried about winning. I already know that we have won as far as the way this works. It's not a matter of winning. It's a matter of making it clearly explainable to everyone what you have done. What you have done is you've shown one thing and then attempted to explain it as another.
You've not won if you think you live in a container. That's ridiculous. And we can measure the density of gases because we know that all gases have relative atomic mass. And based on that, we can measure what the density of those gases
and how do you know that?
Babs, let me...
Because of the periodic table, which says that all gases have relative atomic
So because of a piece of paper that says it, you know it for sure. Got it.
Babs,
well, I'd rather listen to scientists that actually...
Of course you would. Of course you would. I would expect that. Absolutely.
Hold on.
I just wanted to clarify for the audience that what you're talking is bullcrap. We've done that. Thank you.
Babs, what was the point of showing the CO2?
Do you go to Burger King when you want to get your car fixed, or do you actually go to the people that know what they're doing?
There's no such thing as a flat earthologist. You understand, Jeremy?
That's right.
Babs,
I go to whoever I think makes a good burger, in my opinion.
You go to the people that actually know what they're doing. You don't talk to people that have no idea what they're talking about.
No, I don't go to the people who know what they're doing. Because, is your opinion that people at Burger King know how to make a good burger?
Yeah, that's why I don't ask them to fix my car.
I go to the people that have the cheapest price. I go to the people that I personally, of my opinion, make a good burger. It has nothing to do with determining reality, and I would have no way, nor would the people who make that burger, of proving that that burger is the best burger, would they?
All right, Bab,
Exactly.
what was
That's
the
why I
point?
go
So
to the
your
experts,
analogy
not the
is
people that are
in
not
no
the
way
experts.
comparable. It's a false analogy.
Guys, is my mic?
Do you want to
Is
try
my
again?
mic low? Yo, is my mic low?
Go ahead, Jeremy. Go ahead, Jeremy.
Is my mic low?
Yeah, his analogy failed, so
here,
go
here.
ahead. He doesn't have another one.
My mic's good. All right. So, Babs, what was the point of showing the CO2 fall on the scale in the first part?
It proves that CO2 has
Would you say you cut off?
that mass, because we can weigh that mass on a scale.
Hold on, you cut off. What was the point of it?
The point was to prove that CO2 has mass, and we can weigh that mass using a scale.
And therefore, what?
And
That was
therefore, atmospheric pressure is the result of the mass or the weight of the gases in the atmosphere.
Right. So you're
How
saying
long
the
did
gas
you-
falls down. You're saying the gas falls down because it has weight.
That's right, yeah.
Yeah, but what about the 500-pound helium balloon I'm about to let go and watch it go all the way up into the air?
Because helium is buoyant in the mixture of the atmosphere. It's not the
It's got
same
tons of-
density.
It's got tons of weight, though. Look how heavy it is. It's tons of helium we'll use.
Okay,
Over
is
5-ton
that helium balloon as heavy as the atmosphere is, or is the atmosphere heavier? Wait a second, hold on.
The atmosphere is heavier. No, you're right. That
Yeah, check this out, Jeremy. What happens when I go to the bottom of a swimming pool and I have a basketball in my hands? That basketball wants to go to the surface of the swimming pool, right? Because the water
Yeah,
is
no doubt.
pushing down on it. That's what buoyancy is. That helium balloon wants to go up because the atmosphere is pushing down on it. All that weight is causing it to be buoyant. That's what's going on. It has nothing to do with whatever else you guys are talking about. It has more to do with relative density and gravity.
And I get your philosophy,
Right.
I really do, but it looks like mass is an activity. It has so many shifting definitions, and there's no block of mass that we can point to say this is mass. So saying that things have mass, therefore gravity, is a little, meaningless. There's nothing
And
to
why do
refer
the
to. This is
definitions
just
matter,
a
though?
general abstraction to basically a kind of activity that we philosophically abstract.
And why do the definitions matter, though? Why do they matter?
Why do they matter?
Yeah. Why do
Are
they
you
matter?
wondering why it matters that words mean things when you say them?
And looking at cause and effect, why do we care about definitions? We're not
so
trying
we know
to
what we're
we're not
talking
trying
about.
to
The same reason anyone cares about words ever,
Well,
so
wait,
you know
hold-
what you're
but we're
talking
not-
about.
We're
That's
not
the point.
creating an encyclopedia. We're doing science here. So why does it matter what words mean? Someone
Just
else already
the
figured that
basis
out.
Okay.
for your philosophy.
Okay,
You don't have
listen,
anything to refer
I'm gonna-
to except a general activity. So at that point, it's highly philosophical. Where is your cube of mass or whatever? Where is this thing that you're referring to, other than a generalized activity that's philosophically abstracted and defined? Where is it?
Mass exists, Lemon? Really?
As a general kind, yes, but I can't give you a block of mass.
Then
So
you're
what's the
denying
point?
reality.
What's the point, Babs? What's the point to all this, though? What's your ultimate point here?
The point is that we don't live under a container.
But why
That's the
couldn't
point.
why couldn't this all be happening in a container? Why?
Because we wouldn't have stratification without gravity.
Okay, we discussed this though. On a flat Earth, what happens on the sides?
Oh wait, that was wrong. My bad. We would have if it was relative density that was causing the density gradient in the atmosphere, and not.
You cut out. What?
For me.
Ah,
Oh, am I cutting out? Oh, my bad. My computer is acting up. Can you hear me now?
yeah, we hear you.
Yeah, we can hear you now.
Yeah. No, I said the point of this is that in a homogeneous atmosphere without gravity, you would never have a gradient. That's why it doesn't work. If you're trying to say that the gradient is because of relative density, it just wouldn't work the same way.
No,
you need
we
to have a
don't say
force to
that.
make
Okay,
that possible.
So how did you isolate gravity and remove it so that you could show that that
We
is
don't-
what was causing it?
We don't say the gradient is from relative density, bro.
How did I isolate gravity and prove that That's what was causing it.
Is how did you
what
isolate
else
gravity from the rest of it and remove it so that you could show
Wait.
that this doesn't take place without it?
Because what else would make that happen? What else would
Okay,
make
so just to be
gases
clear,
be higher
you didn't do
concentrated
what
at
I
sea
just
level?
asked.
So,
You never
yeah,
did
begging
that,
the question,
and you
he begs
haven't
the
shown
question.
it. Thank you.
Well,
Okay,
we have
you
other
don't say
options.
that.
What have you shown other than say that there's a container
We've
above
shown
us?
an
That's all
egg
you've
in
done.
water.
You haven't done
We've shown
anything.
I'm not the one making the positive
Shown
claims.
an egg in water that changes its elevation when you add salt to the medium and change the medium. There could be a
Hold on.
background medium using the same philosophy and the same reasoning that you use, saying that there has to be some force pulling to the center of the earth or whatever the heck you're saying, to say that there has to be a background medium whose nature changes and decides whether the cloud floats, sinks, or rises, or whatever object you're talking about.
No,
But
it's the
Babs,
only
that's a-
logical reason. It's
You're
only
making the
logical
positive
reason. When you
claims.
start using
Guys.
these other explanations, they defy logic.
But
Yeah,
you don't
you don't
even have
say
a
that,
source for your
though.
force.
Hold on,
So you're
Lemon.
just using philosophy just like us or other people. You have no justification because you have nothing to refer to. No block of mass.
Guys,
Block
Lemon,
of
hold on a second.
We're still
Lemon.
in
Hold on.
philosophical state.
Babs, we're not
Lemon.
saying-
Lemon.
Babs, we're
How is
not-
this all philosophy when I demonstrated this with an experiment at the beginning?
No,
of
you
this?
didn't.
This is not
There's
philosophy. You
justification
haven't
for your
demonstrated
philosophy,
anything.
but there's other
You're the
justifications
ones.
as well.
No, you guys
Babs,
haven't
we're not- we
demonstrated
don't say
anything.
that
You're the
the-
ones with the philosophy. You're the ones that are all word salad. Like I've actually shown you guys
Babs.
experiments. You haven't shown
Babs,
anything.
we're not.
Brandon, can
Babs,
you
we
show
don't
the
say that-
video
You did not
that
demonstrate that there
formed
can't
the
be a
gas onto the
container.
scale, please?
Guys, he said something wrong like 5 minutes ago. I'm trying to correct it. Babs, we don't say that the gradient is caused by relative density. Where'd you even get that from?
That's not what I said. I said the gradient is caused by gravity.
Yeah, but you said we're saying that the gradient's caused by relative density. We don't say that.
So what is a gradient caused by on your model?
There's multiple different things, bro. As you go up, it gets colder. What happens to cold air?
What
goes
happens when
down.
you go up? It gets less dense when you go up.
It
doesn't
gets
get
colder as you
denser.
go up. It gets colder as you go up. What happens to cold air?
Cold air is generally denser because it has the molecules are more closer together, therefore more mass per unit of volume. But that's not true with the atmosphere because we know in the atmosphere it's thinner the higher you go up, so it's not more dense regardless of the temperature.
I'm not saying it's more dense. I'm saying what happens to cold air what happens to air when it gets cold?
Why does that matter? Why does
Because
it
we're
matter?
talking
in
about
this-
Why
where
does it
a
matter
bulk-
why it matters?
bulk
Why
of
not
air-
just
Can
answer
you
the
not
question?
answer the question?
I'm trying to figure out what the context
Just
is.
answer the
Okay.
question.
What
It's
is
a
what is the
simple
context
question.
of the question?
To find
what
out whether or
happens
not
to
you
cold
have
air?
an answer.
The cold air
What
gets
happens-
colder and can potentially form a layer that would keep the gas from going any higher. It can layer due to temperature at that point. As it gets
What happens
higher,
to cold
it
air,
loses
Babs?
kinetic
But
That
energy.
doesn't change. That doesn't
Like-
change the fact that we have a density.
Forms
That
covering
doesn't.
layer
That doesn't
over
change the
gases
fact.
that are contained or whatever.
Make him answer.
Lemon.
Here.
Make him
That
answer.
doesn't change the fact that we have a predictable density gradient in the atmosphere. That does not change.
Yes.
No, it isn't.
predictable
It's
because
not
what
I say we
predictable.
don't
They have a
entertain it
bunch of
further
models to
until he
try to
answers Jeremy's
explain what's
question.
going on.
Come on, guys. Babs, what happens to cold air? Does it go up or down or stay the same?
You tell me. You're the one
It goes down.
with this
Cold
new
air goes down.
philosophy.
You
Why
You know
don't-
what?
why
I'm
don't you tell me
going
what
to
it's
say
about?
this
Philosophy.
again. I'm going to say this again, Babs. I start
I'll
out
answer
on
it.
your. Listen, I start out on your side, and right now you're a fucking baller. You're talking just like the ballers do. Jeremy is asking you. He's on your side. He's asking you a very simple question, and you say, "Well, why don't you tell me the
That's
answer?"
fine. It's rhetorical. We
No,
all
but
know
why
that
does it?
cold
Why
air
does it
goes-
matter? Why does it matter what you think? If you're gonna
All right, fine.
be as
All right,
as
shut up and
dense
let
as to
Jeremy
think
tell
that
you
I'm
why
a
it matters.
baller, then why does it
Just be
matter?
quiet.
What you think?
Just be quiet.
I don't-
Let
Proving
Jeremy
that
tell
you
you
don't
why it
have
matters.
reasoning or logic.
Babs, I don't think you're a baller. Listen, we all know cold air goes down and hot air goes up, right? You know this? You know this happens?
Citation, please.
Come on,
Just
Babs.
the final point.
No,
Were you-
because
were you
we need to stop. We need to stop doing that. We need to stop
Jeremy,
saying
Okay,
stuff
okay, listen.
without
Okay, hold on,
citation.
just real quick. Hold on.
I'm not getting a citation.
Wait,
for that.
A lot of
Jeremy.
stuff you
Yeah,
said without
hold on. I'm going to
citation.
come after Babs real quick right now. Okay, earlier you said that there was a certain atmospheric section that was stratified, right?
I didn't hear Yeah.
I said earlier you talked about one of the levels of the atmosphere being stratified. Is that correct?
I said that stratification does not happen in the troposphere.
Okay, but you did say that there was a certain sphere in which that does happen, correct?
No, I did not.
Okay, well, I thought you did, so carry on.
So, Babs, we know.
I may not be able to carry on because it's getting really choppy for me right now. My signal's all the way fucked up.
Babs, my question was supposed to be rhetorical. We all know hot air goes up and cold air goes down. So as you go up, it's getting colder. Where's the air going to go? It's going to go down. Where's the densest part of the air going to be? If it's getting colder as it goes up, it's going to go down. We also live in a very dynamic system. All the gases on Earth are being produced at ground level, mostly at sea level, which just so happens to determine the 14.7 psi is at sea level. So it's not a mystery as to why we have a gradient, or why we would have a gradient on flat Earth. You feel me? Dabs, you there?
Yeah, I'm here. I just can't talk because my mic is fucked up. I'm listening though.
Well,
Yeah,
at this point, we have competing philosophy. There's no unit of mass. There's no source of the force. I'm going to go with a background medium, just like the water with the egg with the salt in it, that determines what rises, sinks, or floats, and may even give gradients or whatever under a firmamental barrier. That's what I'm going to go with.
Hey, Brandon, is there any chance of getting Bab's first video up with him measuring gas with scales, please? Can you do that?
I think Brandon went on a bathroom break.
Maybe
Yeah, I want to see that gas. I want to see that gas pouring on the scale, Babs, in daylight, because it was very dark. I couldn't see what was going on. But you know as well as I do, when there's CO2 and you see that white, was there any white smoke? Hello. Was there any white smoke anywhere, or white stuff near the CO2? Or was it just all clear and you couldn't see it? He can't talk, his mic's
I think he's
all
gone,
right, never mind.
actually. Yeah, sorry about that. My mic dropped out. I thought you guys were ignoring me. I was like, what the fuck? Wow. They're really ignoring me tonight, man. They're really into this.
No, I haven't even heard you speaking till just, several seconds
Yeah, I
ago.
haven't heard you for a minute, yeah.
That's funny. Yeah, I must have been on mute that whole time.
Well,
it was funny too, because I decided, well, I'll just let them go at this for a minute. But my question was, why does anything Babs say falsify some kind of containment?
I don't know. I've been over this time and time again with Babs on a flat. I've been over this time and time again with Babs on a flat Earth. The gas, there's going to be sides somewhere where the gas is going to need to stop. Unless you think it's an infinite flat plane, then you can get away with that, I guess. But without infinity, without infinity, you're going to need the gas to stop on the side somewhere. You know what I'm saying?
Well, the gradients kind of go against gravity too, because it's not a general gradient. You have very different things happening in the layers. You have one layer of sky going in 90 degrees opposition to another layer. That can't happen on this comet Earth ball rocketing through space, where you'd expect a tail to be tailing the Earth just like with the comets, and or all the air to be going in predominantly one direction. 90-degree opposition like that can really only happen if the Earth is, number one, at rest, motionless, and still. And two, fly in the face of gravity, which would, tend to give you a gentle gradient upward, with everything going in generally the same direction anyway. So this is even that's contradictory.
Yeah, the thing with the tail that you just mentioned, I forget how fast Halley's Comet is going. It's got a hell of a tail. But check that against the speed of how fast the sun is moving with no tail. It's not leaving nothing behind.
It's not consistent. It really isn't.
Can you put the video back on again? Can you, please?
Is it not shown in Discord?
No, it's not showing up.
Okay.
That was something I thought about long ago. If these objects are leaving, trails behind them for miles or however long they say the tails of the comets and whatnot are going, how come if the sun's going? Go ahead.
But the
the tails of the comet are not necessarily trailing behind. It's the result of the solar wind that's blowing off. And actually, the comet can be going away from the sun and the tail be in front of it. And it's due to the solar winds blowing the stuff off.
Would the solar winds blow the Earth's air off of the Earth?
Yeah, I don't know anything about that.
Because I agree that mass is a thing. I just redefine mass as a collection of forces going in and out of the object that make even its interaction with the scale change. With the right, forces going in and out of what we call mass, you can get levitation.
I'm sorry. I just want to go back to that moment of silence when Lemon Bird asked. Yeah, that was a great question, and the fact that he had no answer shows the absolute stupidity of this whole system.
Yeah,
I'm just
so you're
wondering
calling me
what's
stupid?
here.
Are you calling me stupid, Travis?
No, I said the stupidity of the system.
Yeah.
Okay.
Okay, you didn't have an answer. I mean, you typically have an answer for a lot, but that question. Well, hold on. But that question was a simple question that should have a simple answer, and that is, yeah, the solar winds, yeah, they should blow the shit off of the Earth too.
You'd think, yeah.
Why?
But can I just say something, right? I just say something. The fact that he's pouring the gas, okay, he's pouring the gas on the scales. So when you're pouring, you're affecting the gas is being affected, okay. So it's trying to escape from the container. So obviously there's a force on the scales. You know what I mean?
Right.
Yeah, the scale registering something doesn't necessarily mean that the gas has weight. It could be just the gas. It just means there's pressure on the scale. Couldn't it be just the gas blowing onto the scale or hitting the scale?
I checked with his.
He's pouring it. The gas wants to escape, so there's force behind the gas because he wants to escape and it's touching the scales. That's how he's weighing it.
I think we're saying the same thing. It's like expanding out of the cup. And when it expands, it increases the pressure around that area and slightly pushes on the scale. Is that possible?
On this,
Well,
can I just?
Well, can somebody answer my question? Hold on.
Pouring water. If you were pouring water out of it, the scale would react the same, but with probably a greater reaction.
Yeah. Okay.
In 1986, Halley's Comet was going 0.91 kilometers per second, and it had a tail, a huge tail. And Pluto, the speed of Pluto, is going 6 kilometers a second, and I don't see no tail coming off it. And you said
that's a very good question. Yeah.
Yeah, it's weird.
That's yeah. That is a good. I mean, it caused, like you said, the silent. It caused me pause. I had to. I can't answer that.
Well, right, but see, this is the whole thing: is that if we were going to look up a science book that addresses this question, I'm guessing someone has asked this question. But let's say, for instance, they haven't yet asked this question. How would they answer it? Is it just going to be in inductive reasoning? Well, this and this and this, so this. That's not science.
I found a Quora answer from a professor or some dude has asked it. It says, if solar winds are so strong, why doesn't everything on the surface of the Earth just blow away? And here's the answer. That's the top one. Solar wind is not like the way you feel it. There is no air in outer space. Space is a vacuum. In fact, you probably can't hear anything even when two satellites collide.
That's not an answer so far. Yeah, keep going, sorry.
Right.
Oh, that's all right.
Because there is air on the Earth, so that doesn't mean anything.
Solar wind is made of plasma, the fourth state of matter. Liquid, solid, gas, and plasma. The wind is not a stream of air that blows off your roof. It is a stream of charged particles moving at 800 kilometers per second and can blow off our atmosphere. Solar wind comes from the sun. It is produced when the sun erupts, called solar flares, released from the sun's corona or outer layer. We are protected from this wind by our magnetosphere, generated from the poles. This wind is deflected around our force field and results into spectacular night shows called Northern Lights or Aurora Borealis.
Wow. Okay,
What
so
about-
okay,
what about
so
the
again,
move-
listen. Hold on. Again, this is just a a mental construct. Okay, if the Earth is rotating, why don't we feel the resistance of the air against our face moving? Because we know that's what happens when we move through space at a fast rate. Okay, so they just come up with an answer. That's all he did. He just came up with an answer. So our question is, great.
Right. And
How
they say
did-
plasma. Sorry.
Hold on, real quick.
Go ahead.
All we have to do, in my opinion, if I were on the scientific peer review board, I would say, excuse me, how did you isolate the magnetosphere? How did you remove that to see if that's what it was? They don't know.
Exactly.
They don't know.
So does Pluto have a
Plasma has
magnetosphere?
pressure
Or so-
too. Plasma causes pressure. But I want to say one thing real quick. I got to go probably for a minute. But as far as pouring CO2 on the scale, that just further proves density, relative density, because the CO2 isolated is heavier than the surrounding medium. So you might get a little bit of register on the scale. But you try and pour helium on there, and you won't.
That's right.
Yeah.
It's heavy.
It's more dense, so it orders itself lower than the rest of the atmosphere in that room, the medium that it's in, and puts pressure on the scale since it's moving downwards, so it doesn't require any weight. Relative
And then
density
whenever
still
it
explains
spreads out, becoming less dense, it no longer puts anything on the scale to register.
Boom.
And so basically density on Earth is weight per unit volume. It's weight per unit volume.
Right.
The only time they need it to be mass per unit volume is when we leave the Earth. So you could do the scalar. It's basically weight density. Relative density is weight per unit volume until you get to the moon. And,
But his ether bandiness, I think with some of this science stuff, they do come up with just so stories based off of what they think is probable. But some of those just so stories do change, say if the Earth is flat and covered by a dome or whatever. And so we can come up with our own just so stories if we're coming from a different perspective too, as opposed to this magnetosphere. It could be a magnetodome or something. Who knows?
And look, it's all about equilibrium. You take 5 units of you take 5 units of something heavy, right? Say 5 bars of steel, or let's say 5 tanks of carbon dioxide, okay? And you weigh that, you're going to get some weight, okay? Then for each tank you add, you're going to get more weight contained in the thing, okay? You take 5 balloons of helium, and you're going to get. It's not going to keep getting heavier. I mean, the way it's equilibrium. For each balloon of helium you add is the relative density it's not buoyancy, it's relative density. So it's the exact opposite of that. So it all works in equilibrium. So it works out perfect in my opinion.
But the fact is that, like, you're pouring the gas, okay? The gas wants to get out of that container, okay? It's like water; it wants to find its own level. So it's under pressure. How could that's like pour gas onto a scale? That's not accurate. It can't be accurate because it's under pressure. Know what I mean?
Yeah.
I think a trick has been pulled here too, possibly with this concept of density. Now, if you take a piece of paper and you crumple it up, making it more colloquially more dense, okay, then you could set up a fan, and the fan wouldn't necessarily be able to hold up the paper. But if you stretch it out, okay, and make it colloquial less dense, then it'll be able to hold it up, and they'll call that aerodynamics. But I'm wondering now, like, you can't pull something apart and make it shorter at the same time. So I wonder if they've taken aerodynamics, that basically they've called it aerodynamics. I'm wondering if aerodynamics is actually a function of the mechanic density. Because whenever you stretch something out or basically make it more aero, or to where it would catch, like with the piece of paper, you stretch it out, it will catch more because you're stretching out the area, you're making it less dense, so it's easier to keep it up. And then they try to also transfer this idea over to a gas, which is not, gas is not a thing. It's a description of really an area of not clean air, right? Or just not just air. So it seems like there's possibly one or two tricks that they're pulling in the way that they're describing this thing that they're calling the density of gas.
Well, we think of either a push or a pull moving an object, which is where gravity would tend to come in as the push or the pull that makes this happen, and or vibration and pressure mediation. Because if everything's vibrating in place, all you got to do is scoop out a part of the medium and something will vibrate in to fill up that space, up, down, left, right, or whatever. So those appear to be the main possibilities: vibration and or pressure mediation, frequency or whatever, versus a push or a pull from some sort of point source.
Pressure, yeah.
You know, that thing you said about crumpling up the piece of paper, it's like, we know that the material itself hasn't increased in density, but it does occupy overall a smaller space. So is it just aerodynamics? Because that's another factor in all this, right? Is the aerodynamics.
That's what I'm saying. Have they hijacked aerodynamics, and instead of calling it what it is, which would be a function of the mechanic of density, but instead they've separated it out into its own thing to keep people. I mean, that's getting a little bit more into the they thing, but has somebody somewhere along the lines, just like they did with Einstein stuff, hijacked this thing and turned it into something else that it actually isn't?
They've had to add so much because of gravity. To maintain gravity, they needed what you say with aerodynamics. They needed extra equations with buoyancy. Even though they work out perfect if you use weight per unit volume, you're not using the weight of something to figure out the density. You're using the density.
Just try to think of an example of where you make something more aerodynamic but add density at the same time.
But see, Brian keeps saying weight. Every time you say weight, you're saying gravity.
No,
you realize that?
No, that's
Not
the problem.
Relative density, man.
You guys built your model into these common terms that we use every day. When we say weight, we're not talking about F equals ma. We're talking about
right. In other words,
weight.
look, and let me explain this to Howard. So in other words, when I say weight per unit volume, so when you get to helium, you get negative. But the more helium you add, the more negative you get. So the more carbon dioxide takes the carbon dioxide I get heavier. So it's weight. So the weight goes negative. And there's an equilibrium. There's a zero. So instead of everything there being no negatives, there is a negative, hydrogen and helium, because it's less than the surrounding environment. But that all stays the same in water. It's just a different scalar. And it all depends on the medium you're in. So no, weight does not mean gravity. That's my best way of explaining it.
But if you don't calculate the acceleration, you don't get a value.
What?
If you don't calculate the acceleration of gravity, the downward acceleration, you don't get a value for what you're weighing.
Per second. It's still 9.8 meters per second in one atmosphere. Okay, solids in one atmosphere. Okay, that doesn't change.
Yeah, they measured that before they ever came up with the equations, dude. I mean, that's just the effect that we see on Earth. That's an empirical truth. We're not questioning that things accelerate when they fall. For something to move, it has to accelerate. So,
but see, there's the disconnect. Why do you deny or I mean, it's almost like, to me, it's like you're refusing to recognize that downward acceleration as gravity. It's like.
Right, because gravity itself, as described, is not provable, detectable, or experimental.
Here's why. Because exactly what Bob just said. You've created this story that you've handed us, and you've wrapped it all in the equations. So you've got this empiricism wrapped around your theoretical heliocentric model, and you hand it to us, and then when we say, well, wait a minute, we don't believe in all this other shit, this, sun 93 million miles away and mass attracting to the center of the Earth, and then you say, well, stuff accelerates when you drop it, so it has to be that way. No, fuck that. You guys are the ones that married the two.
F equals ma and stuff when to leave the planet, Howard. If you don't leave the planet, you don't need F equals ma. You don't need all this stuff, bro.
Yeah, you do. To calculate a trajectory, for instance, a ballistic trajectory, you have to use little g. I think is little g. Yeah.
No, you
I mean,
have to use 9.8 meters per second squared, but F equals ma is the same as force equals weight times acceleration, or the density.
See, when you
the relative, you have to add in the relative density, but I think George did it, man. I have to go back.
We aren't
It was me and
denying
George,
that
Brian.
the thing takes place. What we're refusing to accept is their explanation of why it takes place. That's all.
Yeah.
Yeah, we don't understand because gravity.
That's a big
in
question.
their model, gravity works both ways. Okay, and like, does gravity work in an opposite way? Like we are told that the moon creates the tides. How does that work?
What was the question, Gadget? Can you repeat it?
Gravity, does it work two ways? The moon creates the tides. How the fuck does that? Well, like, the tides are created by the gravity of the moon. How the fuck does that work?
But that's going a little bit further into it. All I'm trying to clarify to him is that we aren't denying that things accelerate, and when sometimes they accelerate down. Like nobody, whenever you drop a ball, no one's denying that the ball goes down. Okay, and that's a false argument. No one's making that argument. All we're saying is when they point and say see gravity, we're saying no, possibly something else. You can't prove that it's gravity. You can prove that it goes down, but we weren't questioning that in the first place. We're just questioning the reason that they gave for why it went down. If I said green goblins and you said gravity, we could both show the exact same amount of evidence, verifiable, credible, repeatable evidence for both of those things. It's just you've clung to gravity rather than finding out what the actual reason is.
You got to call it something.
That's right. You got to call it something. And gravity is a fine name as long as it doesn't carry with it all of the other baggage that they have now hitched up to the back end of gravity. If we can let go of that trailer, gravity's fine.
The atmosphere is pulled to the earth by gravity. There's no Coriolis effect and all that bullshit. How the hell does the moon make the tides then? Can you, like, does gravity go up and down or what? What's the story with gravity, please?
I think that's a fair point. Why don't we feel like a pressure difference in the air when the moon passes overhead if it's pulling everything off the face of the earth? Why aren't we lighter? I'm sure they've got some bullshit explanations for all that stuff, but it just doesn't make any sense.
Well, let's just go back real quick because I do believe that words are important. And Howard, I'm not trying to be pedantic or patronizing. Do you know what the word gravitas means in the Latin?
Well, let me.
Hold on.
No, I did, but I couldn't give you a definition. No.
Grab or pull, is it? Grab or pull, no?
No, it means heavy.
Right,
weighty. Their excuse for why the.
Hold on.
Go ahead, Travis.
Hold on, just real quick. Hold on. It means heavy, right? Okay, so that's conceptual. So even the word gravitas, even the word that they get gravity from, contains the concept that we're putting forth that it is simply heaviness, weight, density. The concept of gravity in your model depends upon a construct that reshapes not only the Earth, but the entire universe. But that's not what it meant originally. It just simply meant something that has weight to it. The gravitas of the situation.
Right.
I just wondered if you were skydiving on a full moon, okay, you jumped out of an airplane, would you fall slower than another night? Like, because the moon is pulling all the oceans, 75% of the world, or 95, is it? Oceans, millions and millions of water making the high tides. Would you fall slower or faster?
From my perspective, the issue on the tides, even though it's a huge, massive action, I would call the tides to be a very subtle influence.
Subtle on a planetary scale.
Yeah. I mean, relatively speaking, I mean, it is a big mass and it is a big mass of water, and it's very forceful. The tides are. They're actually making energy, and are experimenting with making energy with tides. But as far as it, like you expecting it to influence, us, I really wouldn't expect it to.
Well, yeah, it just
Yes,
influences this
when water
stuff.
moves.
It influences salt water, but it doesn't influence fresh water. It influences salt water, but it doesn't influence humans or the atmosphere. It's inconsistent.
So
Well,
I
the
agree
Great
with
Lake.
that because that was my problem earlier when I was saying, okay, well, you have this one vector to the center of mass, but the gas is going in other directions. Like in this same sense, the same thing is happening.
Yeah, very similar situation. I live on the Great Lakes, by the
You're
way, and there are
saying
no tides.
it's on a sorry.
Oh,
Yeah,
no.
that's what I was saying.
On a planetary scale, you said. You don't think it would make much difference, but we're talking about us as people and things made up of molecules, right? And particles and all of this. And why would the water be affected but not other things? Why?
Yeah, exactly.
Don't know.
The reason for the not having tides and little things is because they say you need a large body for the gravity to affect it. Like it's not going to affect the top of water.
But Jeremy, there's smaller bodies, saltwater bodies than the Great Lakes that have tides. Okay, so it might have something to do with that. When you add salt to water,
Well,
you make
that's
it more
something to look into.
electrically conductive.
If that's true, if there are smaller bodies than Lake Michigan, and I'm not aware of these, but smaller body that is salt water that has tides, but Lake Michigan doesn't have tides. Is that right?
Lake Michigan doesn't have tides, no.
Mediterranean doesn't have tides. That's a
But where's the body of salt water that Brian mentioned that does have tides? Where is that at?
Right. What's that smaller body of water, Brian?
Man, I have to check into it, man. I heard it from somebody, so I'd have to verify it for myself. But he gave a couple examples. I think he said the Dead Sea, or maybe even the Salt Lake got a little tide. I have to double check that though. I will right now.
Okay.
Yeah, that would be interesting.
Yeah, that I can't think of anything that would make sense. You would have to have an incline. If you've got a contained body of water, and then you have, I mean, with the tide, it's like, is there a tide only in one geographical location, or does the water recede altogether so that at the perimeter of the water all the way around it recedes a foot? I mean, everywhere, because then where'd the water go, right? Did it lump up in the middle? So I'm dubious as to whether or not that's true.
Yeah. Okay. Well, you guys keep it going for a minute. I'll be right back, guys.
The idea that it only affects larger bodies, but it's still a function of gravity somehow, well, then why is the Earth keeping us allegedly attached to the Earth since we're not large enough bodies to be affected by gravity? And
I don't know that I followed that. Say that again.
If the claim is that the moon's gravity is causing the tides, and you have to have a large body for the gravity to affect you to make the tides, or affect the water to make the tides, then why are we affected by gravity of Earth if we need a large body to be affected by gravity?
Well, if gravity was really the force that they were talking about, we wouldn't have to make so many exceptions for it in the first place. And so it appears to be a general philosophy.
I'm not arguing that gravity is the force. I'm just saying that that's what their claim is, and that doesn't make sense, that it has to be a large body to be affected by the moon's gravity, but then somehow all these small objects on Earth are still affected by gravity without having the large body. Like that's
yeah, I think
gravity did what they claimed. If they claimed it was doing. if gravity did what they claimed it was doing, the best time to sell gold when there's a solar eclipse antipodal from you.
Yeah, you can make bank, right?
You could just buy gold when there's a solar eclipse above you, sell it, solar eclipse antipodal to you.
Yeah, you could basically base economies on it.
What you think, Left Lane?
But I understand the point that the guy was making before. Not to say that your point wasn't good, Jeremy, but I just wanted to say I understood his point because the guy said, on a planetary scale, I don't know how much it would affect, the smaller things on it. It's basically what I was hearing too. Like, and that's why I was asking, why not?
The thing
Like,
is,
okay, for instance, okay, well, what about the clouds, right?
yeah,
on a cloudy day when the moon is like you can't see it because of the clouds. Why isn't it sucking up all the clouds out of the sky?
Exactly.
I'm trying to bubble off these gold buys and sells here. Let me find out.
The thing is, I don't understand, and I don't agree with it. Is we're sending our kids to school today, okay, and they're teaching kids about gravity. We don't even understand what gravity is, what it is. Like they're saying, gravity is pulling us to the center of the earth, and yet the moon is pulling the tides. Where is the difference? Where's the max from pulling and pushing or whatever? I don't understand that, and yet they're teaching that in the schools. We don't know what gravity is.
We don't even know that gravity is.
Fair. I don't think it's fair. It's not fair. Jesus Christ. That's doing me head in.
Well, the thing is, we have not only a changing activity where it's pulling down huge masses of ocean but leaving a fly alone, but we have a changing quantity because they define mass at will. At one time, it's the earth and the water and the air. At one time, it's just the ocean. It's changing not just the activity, but the quantity. And at that point, I'm calling metaphysics.
Yeah.
What can't you, if you're going to talk about masses, or you're going to talk about cumulative masses or individual mass, I don't see anything wrong with that.
It's just
Left Lane, when the best time to buy gold would be?
An interaction.
Is gravity pushing or pulling? That's what I want to know. Is it pushing or pulling?
Left Lane, when's the best time? Yeah, when's the best time to buy gold be when there's a solar eclipse right above you, since it's pulling all the mass?
If there were a significant influence, the answer to that would be yes. But whether it actually does influence,
it's a significant enough influence to pull millions of tons of water.
Yeah.
Yeah.
Right, that's what I'm saying. It's not like it's pulling up a few molecules. It's moving around an entire fucking ocean, and it doesn't affect anything smaller.
And then on top of that, allegedly pulling up the earth underneath that ocean to make the tide on the other side at the same time.
We should see blue whales flying in the sea on the full moon.
I'm fixing to go off in a valley, so I'll be out for a bit.
All right. Thanks, Howard. We have a couple of people who haven't joined the show, or one new guest to the show, Elijah F. What's going on, man? I can't remember you being on the panel before. How you doing?
Hey, man, just chilling. I saw that this show was going on my YouTube, and I know Ranty from Nathan Locally show, so I saw the Discord app and the Discord link, and I joined.
Well, that's cool, man. Yeah, you're more than welcome to join at any time. It's always nice to have new folks on, and Ranty handed the show off to me a couple months ago. He's on to bigger and better things, planning a trip to Australia and doing all kinds of. He's got a new podcast, which I should plug for him, which is called Almost Unbelievable, and he's got a channel called Almost Unbelievable and a podcast, I think, on Spotify that he does with Conspiracy Cats. So if anybody out there hasn't checked that out, go check it out.
Yeah, I was kind of backtracking, but the 3 seas I found that were comparable to the Great Lakes that are tidal. It said the Caspian, the Baltic, and the Black. Wait, let me see. The Caspian, the Baltic, and the Black Sea.
Well, salt water is magnetic, so that would explain if we're not seeing tides on fresh body waters, but we are seeing them on salt water bodies. Could it be something to do with the fact that salt water has a
salt water is
it's not a big a tide, but it's bigger than the Great Lakes tide. But they're comparable to the size of the Great Lakes. But I was going to say that's what they call an inland body of salt water that's real big like that. They call it a sea. That's the difference between a lake and a sea is the salt. And I was just bringing up a few because that's interesting to me. You know, that because salt we know makes it conductive, and if the Great Lakes don't have a tide, and the Baltic, the Black, and the Caspian Sea do, that's food for that's worth questioning, in my opinion.
Yeah, you know, my statement was sort of untrue because they are said to have very small tides, less than 5 centimeters. I just looked the Great Lakes, which I knew, but it's like nothing. You can't even see. You can't see it. No one. I've never noticed any difference in the water level, and I have never heard anybody talk about a tide all the years that I've lived by the Great Lakes, ever.
You want to hear what NASA says about tides?
Yeah.
Seawater is an electrical conductor and therefore interacts with a magnetic field. As the tides cycle around the ocean basins, the ocean water essentially tries to pull the geomagnetic field lines along. Because the salty water is a good but not great conductor, the interaction is relatively weak.
Whoa, what
shout out to NASA.
Wait, say that. Read that one more time. That sounded to me like they're saying that the magnetic field is rotating. Is that right? Read it one more time.
Here, I'll read it again. Seawater is an electrical conductor and therefore interacts with the magnetic field. As the tides cycle around the ocean basins, the ocean water essentially tries to pull the geomagnetic field lines along.
What?
Because the salty water is a good but not great conductor, the interaction is relatively weak.
Yeah, it doesn't make any sense, and that's what they expect. They expect us to go, what? And then just move on.
They had to. At least they came up with something since gravity ain't a force no more. At least they came up with something.
Guys,
I like that.
The Mediterranean Sea.
You like the fact that they just came up with something. That makes you happy.
It's comforting.
I like the fact that they're going along with the fact that gravity ain't a force. I like that fact.
No, it's not a force. It's not a force. The Mediterranean is a very salty sea, but it doesn't move. There's no tides in the Mediterranean.
So you're happy they didn't try to like force feed or like shove gravity into another box, basically, or into another hole.
I don't understand why we've been getting this nonsense from the Globers this whole time about how the sun and moon are pulling on the water, but NASA comes out with this magnetic thing.
Yeah, what's up with
NASA
that?
Not going along with it. I don't know.
It doesn't even mention the moon.
I'll post this. Citation.
It takes time to write scripts, guys. All right, so they needed to come up with something to say in the interim while NASA was getting their crap together to figure out how they want to respond.
I'm going to wait for the next full moon. I'm going to stand in the garden for the next full moon. I go out to the garden and try to get a hard on. It might give me some.
Well, listen, that's the whole thing, right? So
might pull something.
The question becomes when did the moon first become associated with tides, right? So it all goes back, again, was it an observation or was it a concept of gravity? Well, we know that mass attracts mass. we know, excuse me, that the moon is rotating and that the Earth is rotating. And we know that the moon's orbit around the Earth is what it is because of orbital mechanics. So that the moon has mass. Well, what has happened when the time? So all they're doing is correlating. They're correlating. But let me just ask the panel real quick. In your opinion, if the moon is full and you're on the beach and the moon is above you, would you expect a high tide or a low tide?
I would expect a high tide.
High tide.
Me too. I would also expect the tide to be higher.
Okay.
Super high tide.
Okay, wait a minute. Let me restate what I think I should understand. The moon's mass pulls the oceans to it. So I don't understand if the moon is pulling the water towards it, how you're going to get a high tide, because the high tide is when the water is higher on the shore. Wouldn't you get
right? I see what
Yeah,
you're
it doesn't
saying.
line
It would
up.
draw it up, which would draw it away from the shore. You're saying.
Yeah.
It doesn't line up anyway, man, because there's two very high tides a day. The only reason they say it's correlated with the moon is because it falls behind about about an hour and such minutes every day. But there's two low tides and two high tides a day in the typical in your normal area. But maybe the moon is a superconductor, man, and it's it's a superconductor and it's going around us and it's magnetic, man. I don't know.
Every 6 hours, yeah. Every 6 hours.
First of all, the sun and the moon circle around in between the tropics. So you would expect there to be, that's where you would expect to see the biggest deviation of tides. And that's not what we see.
I must say, from everything I've studied, man, and just being around the tides my whole life, the moon has something to do with the tides. But I don't know what. I think it maybe the moon, like I said, maybe it's magnetic. Maybe it's. I don't know. I'm gonna try and make I'm gonna try and make some correlations on that, man. That's an interesting thought.
Yeah, well, think about a high school, middle school science field trip. We're gonna go to we're gonna find out when the high tide or full moon, whatever. We're gonna go camp out for a week, and we're gonna show you how to gauge the moon. I mean, has that ever been done? I doubt it.
Well, I have a simple question. If most of the oceans are unaffected by tide, why would the moon affect and cause just shoreline phenomena? All the oceans that are salt water, whatever, should be affected. But most of the oceans have no tidal change at all. Go figure.
They weasel out of it by saying, "Oh, it also has to do with the shape of the land masses in between the water and whatnot." Because you'll have
I can agree with that. Definitely, water does not compress. If it comes up a valley, it's going to rise higher at the surface because the walls of the underwater valley.
What do you mean it doesn't compress, man? Look, a teaspoon of water on a quasar, man, weighs as much as the sun, right?
Yeah, well,
they can't even compress water, but they got a teaspoon.
I know. In the Bay of Fundy, the underwater, geology that's there causes a 50-foot change every tide. There's an empty bay, and then there's 50 feet of water every day, twice a day.
I'll be damned. That's crazy.
50 feet.
Yeah, I watched that video. That's pretty cool.
Moncton, they have a tidal borg every time there's, every day, twice a day, there's a waves that run up the river, the Moncton River. They tried to put some barriers to control it, and the Borgs just tore all their investment apart. They just leave it to nature now, that whole area. But we have a tidal Borg,
Jim, but was it 5% of the oceans are unexplored on Earth? And yet we're sending
Well, even at that, like I say, the tides are mostly a coastal thing related to the land masses, because most of the oceans have zero tide. No tide. No change in elevation. That's a serious problem for the moon, causing these oscillating tides.
I've got a map up of the tides, the tidal nodes. I should be sharing it in Discord, and that's pretty interesting. These tidal nodes where all the tides center around. I'd be curious how they explain the pattern of this. And another thing is, it reminds me of a design for a filtration system. If I was going to design a filtration system for the Earth's oceans.
Heat pumps. This is hot and cold too that's represented here.
Those tidal nodes is where
temperature between different density masses, as you always say, causes movement. Ocean currents, air currents.
Go ahead, Jeremy.
Those tidal nodes, there's no tide there. Why are we seeing no tide when there's why would I don't understand why we would see no tide there in the middle of the water. It's not even near land.
No, where I live, it's red. We get massive tides. Ireland and France, Spain, along that coast, we get loads of tides.
Yeah, you got huge tides. Hell yeah.
Look at the east coast of America, green. You get tides in the east coast of America. Look at Alaska, loads of tides.
Yeah, we get about 5 foot, I think. Really, yeah, but probably between like 4 and 8 foot, I think.
Yeah, it's about what it shows. Yeah, it's kind of weird, these patterns. It's and I see that there's these arrows around the nodes that show which way the tides go, because they circulate around these nodes in certain directions.
Yes, those are like underwater tornadoes. There's nothing else to call them. They're rotating cylindrical like vortices. And that's the direction of their spin.
Yeah, exactly. That's what it reminds me of. It's like it's circulating the water around, like keeping the water circulated and like filtered or some shit.
Like a magnetic motor, a stirring.
Well, now, why would the moon create these nodes? You know, why?
Can you get a map?
It's
can you get
not creating those nodes.
Can you get like a simulation up, Brandon, of where the moon is above it and when the tides are how the tides are going?
Oh,
yeah, a globe map. That'd be cool.
Overlay them. That's all I could suggest.
Yeah, like where's there a high tide and then where's the moon at? I don't know.
Yeah, that's what I'm going to look into, Jeremy, because if you think about it, okay, so if it's not the gravity of the moon, not even NASA claims that, but I can, the times of them are correlated with the moon. You got to look at the time of the tides, on a daily scope, and it correlates directly with the moon, falling behind a little bit each day, just like the moon does, which is probably why they thought that to begin with. But my point being, I'll get right to the point. Well, my point would be this:
spoil that.
Yeah, it might. No, I ain't trying to say nothing definitive, but I'm just saying it. Let me get to the point. Point is that whatever's causing the tides, the way we're seeing that, could have something to do with the moon's circuit. You know what I'm saying?
It could. I mean, anything that goes in a cycle is going to have some kind of correlation with the celestial bodies, because those go in a cycle too.
Because a rooster crows in the morning, but that doesn't mean it causes the sun to rise.
Yeah. Oh, here they've got a little diagram for how this is supposed to work with the oceans being pulled out into their fatty earth. Handlebar, or what is that called when you have extra weight around your waistband? Muffin top earth.
And the actual track the moon takes around our so-called Earth, and it's a spirograph. If you ever played with spirograph when you were young,
oh yeah,
it's the same damn thing. So our moon, over I don't know how many cycles, I have a little video of it. Really, it's like has warbly and well symmetrically geometry spinning around and forming these like spirograph perfect loops. What? Really? It's just perfection. But anyway, if you want to see that the moon and its orbit around the Earth over several cycles, I can post it. I'll post it in back, and you tell me that's controlling the tides.
Yeah, post it, man.
It's not even the same symmetry as the tides. Zero.
Well, I mean, if we get two tides a day, the moon's not going around 2 times, so I don't understand how they even get this.
Come on, guys, look at the equator. Look at the bulge under the equator.
Yeah.
I mean, come on. Even the guys that they landed on the moon back in 1969, wouldn't they get sucked into the moon? Wouldn't they? if the moon had that force.
Well, you think that if the moon's as bright as it is from where we are, that if you got close to the moon, it would be this huge spotlight, just by looking at the inverse square law of luminosity. But all of a sudden, the Earth is this dull rock when they arrive, and it's this dusty, dull rock or something. It doesn't make any sense.
Gadget just made a really good point. Gravity's supposed to be stronger the closer you get. So by the time they got to, if gravity's pulling all that weight on the on the Earth, it should have been doing a lot to the astronauts. How's it 1/6? I don't know. I don't get it.
Okay, I posted it in the back, and again, the moon is supposed to be coming closer and farther, and you know, there's a pull, a closer pull when it's closer, and supposedly a farther tug or less tug when it's farther. But the orbit, if you look at it, it's like a kid playing with spirograph. And you're going to tell me that a multi-billion-ton stone is doing that around us? That spirograph dance? I don't think so. But there's the sun, the earth, and our little moon doing its spirograph around us.
That's what we're supposed to be doing around the sun? That loop-de-loop right there?
Absolutely. Absolutely calculated perfect.
And it's, you know, it's just an inversion of reality somehow, a mathematical inversion.
Really? Yeah, they learned how to play with mathematics, and this is from spirograph and just some calculations there. No more, no less.
It's fascinating. It looks like an egg.
Brandon, did you see that post? Do you see that post? He said that's actually slowed down. We slowed down.
You notice our sunny side is always facing the sun, right? But we're revolving around an axis at the same time. Now, when the moon is behind us, you know, it's supposed to be on our dark side, right?
Right.
When it's behind us, there's one day a year, it's on my horizon at a certain place. It's over Central Africa, right over the Nigerian-Congo border. Or Nigeria and, well, anyway, Nigeria. I think it's Congo, I forget. But it's over the heart of Africa. I shouldn't see it. But when it's right on the horizon, big and bold, that's exactly where it is. I'm looking straight across at it, and it's over Africa, across on this flat plain. So I know if I had to follow my senses, I'd follow that path directly in front of my nose to get to Nigeria. Or Nigeria, I forget what the fuck anyway. But that's my point. It's ridiculous that our moon is doing this spirograph beauty around us, weighing millions of tons, and us being held by the sun, and then it being held by us and the sun, and it's making a spirograph. It's from a kid's toy, and it's from fiction, all this stuff.
No, it's ludicrous.
But there's our spirograph world, our cartoon world.
Like I said, if the moon's really pulling on all the mass, you know, on mass on Earth, best time to buy gold when there's a solar eclipse right above you, and sell it when the solar eclipse ain't a portal. You get paid.
This show does not provide financial advice of any type.
But you really think that that type of symmetrical orbit could really be happening between us, just us, the Earth, and the Moon? Or the Sun, the Earth, and the Moon?
Come on.
And that doesn't include... You want the other planets in that shit show?
Jimbo, think of all the opposing forces just in that etch-a-sketch that you just shown there.
Imagine you're on a speedboat, or you're on a tow line, and you're on water skis behind a speedboat, and you're doing U's behind the speedboat as it moves forward. Well, when you get to the back, you're under the most force, then you're going around that arc, and you catch up to the boat laterally. Well, you're almost going the same speed as the boat. There's no force on the rope.
I can barely hear you, Jimbo.
Well, when you're being towed behind the boat, and when you're right behind the engine and the boat's moving forward, there's the most pull on your rope. But you cut and you go on an angle towards the side of the boat, you catch up to the side of the boat and the side of the engine, right? There's not much force on your rope. And then you ease back, and then it speeds you up again, and you whip back to the back of the boat, and then, hook around.
Jimbo, this is beautiful, man. This is and this is just now 2 bodies, right?
Yeah, this is just Earth. Just 3 bodies. You got to count the sun.
That's right.
And programmed into
motion.
Yeah, and the sun's supposed to be moving too, right?
Yeah, absolutely.
And then the solar system is moving, right?
But then from pure math and pure algorithms, and you can see it right here.
The moon is check that out, Brandon. The moon is moving away from the Earth, apparently, from NASA.
Oh yeah.
Well, it's moving towards and away and towards and away.
Last
towards
time
the
I
sun,
counted,
away
I
from the
counted
sun.
11 different motions. Last time I counted, Jimbo.
Your 11 vectors, yeah. I think that's a good point, though, about that water skier. Yep. You think about the forces involved in when you're being towed behind a boat, and then you scoot over to the side of the boat, and you can drop back very easily, but, you know, there has to be a speed change for that moon to do that, right? And that's why they had to have it a vacuum, because it's mathematical. So they had to make it work without any resistance or any extra work to get into position.
That's right, Brandon. They had to put their mathematics in there.
Yeah, the vacuum is the key to their math. Having the vacuum of space.
Everything
this
is
really
with that.
A complicated or elaborate program. It's a page or two long. It doesn't take up a supercomputer.
Yeah.
Just the fact that they've been convinced that they're traveling officially. I say 4 with my. I added some juice in there. But officially, it's 1.5 million miles an hour. They think they're traveling at this moment as we speak right now.
Yeah, exactly.
And in a perfect spirograph motion. We're spirographing. We should feel all kinds of motion, including freaking our poop coming out our asses because we're moving forward towards this great attractor at breakneck speeds.
Well, somebody, you know, the battle cry of the heliocentrists is it's all relative, right?
Of course, of course.
This symmetry of orbits, which should be just round and round in a circle, is impossible. It's lunacy. It's ludicrous. You know, if you put a ball in a sock and spin it, your ball in the sock is not going to be spinning and rotating around an axis and stuff, right?
Yeah, this supposedly happened by accident, and it all works just like in harmony like this to maximize the amount of space on that little tiny ball. That little tiny ball spins just perfectly and is tilted just perfectly to maximize the amount of usable space in one cycle on that little ball to support life. That's all accidental.
So let's
like
calculate
a Swiss watch, Brandon. It's amazing.
This ball Earth and send a rocket pixel out to the surface of the orbiting moon now. Add that to the math in this program.
No shit, yeah.
Swiss watches have a creator. Just note that.
Yeah, I was just gonna say, just real quick, you know, conservative Christian.
You're cutting out, Trevor.
Traditions are heliocentric. Okay. How about now, real quick?
You're good now. You're good now.
Any better?
You're good. Yeah, you're good.
Traditional Christian, or historically traditional Christian churches are heliocentric, and so they attribute that kind of precision to a creator. God tilted the earth at 23.6 degrees, yada yada yada, all of it.
But it's not based in the Bible, because in the book of Job it says that he pressed out clay, flat like clay.
The Bible is symbolic, Lemon Bird. That is not literal. Stop. It's not literal.
But the Bible is a multi-genre piece of work.
No, it is not. No, it is not. It's 100%
history, allegory, poetry, all that.
No. All of those genres fall under one genre, and that is symbol. The symbolic language of the Bible overrules all of the others. They fall in line behind symbol. Sorry.
Well, there appears to be history in the Bible as well. So
okay, listen very carefully. Listen very carefully. Listen very carefully. History used in the Bible is used symbolically. Okay? You might refer to Noah's flood and say that was an historical event. That was an historical event. But its proper use in the Bible is allegory.
But it's history that matches all the fossils we see very nicely.
Excuse me?
It matches all the fossils we see very nicely. So it appears
the Bible doesn't say anything about fossils, Lemon.
It says something about a flood. And a flood would tend to bury a bunch of organisms in a bunch of fossil layers.
Listen very carefully. You are simply correlating two ideas.
Oh, you guys are done?
Hello?
I thought that was going to go on for a while.
I don't want to be too much of a dick.
All right. Since when? No, just kidding.
That's funny. Hey, that brings me up to one more point, man. I pointed out in that last video I made that it was like take off from the presentation that I didn't really put together the way I wanted to. But in that video, I pointed out they say the Earth's orbit, elliptical orbit, okay, is supposed to be the reason for the bigger loop of the analemma. But if you look at the distances from the sun, okay, the given distances, they only vary by 3.4%. Okay, there's a lot wrong with that. For one, the bigger loop at the bottom of the analemma is way bigger than 3%. For two, if you look up the projected lunar analemma, the distances that they claim varying from the moon are 13%, and it makes up an identical analemma. If you map it out, you know, you have to throw some simulation in it, but it's identical. The part we do see is identical with the in 1 month. The lunar analemma over 1 month is the identical same that I could find as the sun's analemma over 1 year, and that's a 13% difference in distance to a 3.4% distance difference in distance. And just like I said, right on the face, the loop is way bigger change than 3%. So it falls on its face right there, if you ask me.
I'm glad you reminded me. I got to go back and watch that. You're happy with the way it turned out then? I see it's about 14 minutes long. I've been meaning to watch it. I haven't gotten around to it.
There's a lot of good shots in that, man. Yeah, if you could post that video, man, everybody watch that if you get a minute.
Hey, did you ever answer my question? Whose Mustang is that?
That's mine and my wife's, man. It's you know, ours collectively, but it's hers technically.
Well, wait a minute. We got to look at this Mustang.
I'm gonna concede. It's in the video.
Is it a manual?
Nah, man. It's no, it's an automatic.
Oh, that's like
right.
That's a newer one. That's like a 2000.
Yeah, that's a later
16,
model.
17?
That's
17. Yeah, it's a 17. It's pretty nice, man. It's beat up a little bit, but it's nice. It's a nice vehicle.
You got the V8?
It's not
we got time.
Hold on.
Nah,
you got the V8,
it's
Brian?
A V6, man.
It's a V6.
Nah, it's a V6.
Okay. Well, that's your wife's, right?
It looks like cowl induction, but
Yeah,
it's kind of
that's her.
weird to me. Is that cowl up there on the hood? What's on the windscreen?
It's like I think it's called like a power buff or some powder buff.
Yeah, it looks like the trap wind push it back towards the intake, like a cowl.
Yeah, man, I'm not real into vehicles, but I'll tell you what, that thing, you know, for a 6-cylinder, it'll go though, man.
You're not into vehicles. You got like,
coach, you said.
I see 1, 2,
I mean, I'm not
3, 4, 5, 6 cars right there.
Yeah, two of them are one of my daughters, and the other one, yeah, just the white truck and the Mustang are mine. And I drive the white truck, and it's, you know, I use it for work and for driving around.
What's this shit?
And the car, you know, that's my.
What's this H symbol right here mean, Brian? We got to talk about this.
Hold on.
Is that a Honda?
Hold on, let me see. Yeah, that's my buddy who works for me.
Oh, okay. All right. You're good.
Yeah,
then.
that ain't mine or my daughter's, man. I will admit that.
I'm just giving you shit, man. Yeah, I got to go back and watch this. If anybody out there, take a minute and go to Brian's channel. I put the link in chat and subscribe to him. You want to watch somebody who's got a lot of energy and is out there doing shit, just trying to think about it. Go out and check out his channel, Flat Earth Tests. It's good stuff.
Oh, Brian always keeps it moving. You know how I know? Every time he comes in here, he sounds like he's out of breath.
That's because I'm usually pacing around, man. Yeah, you're right.
But if we got time, can we talk about like horizontal lines?
Yeah, why don't you give us an update on what you're thinking there, Jeremy, and go for it, man.
All right, here's what I want to say. I looked into Bev's thing, and what he's going to do is solid. I like it. I like what he's doing. I also would like to try other things, though. I wouldn't want to just limit ourselves to that. So if anyone has any ideas, we still want to hear how to make a horizontal. I have an idea of, or not an idea, more of a concept. Like, we can make a straight line vertically, easy. Plumb lines. They go down. It's a straight line. I'm wondering if there's a way to transpose that or transfer it horizontally without, fucking up the integrity of the straightness, so to speak. Any thoughts?
No, but that gives me something to think about for sure, man. I've been thinking on the same lines as you, like on the bridges, on the pylons, like making a mark with a boat. But I like your idea with drawing the straight line, or a couple other people have mentioned that, but I've mainly heard it from you. But the best thing I could really come up with is the bulkhead, drawing it. But like I said, we don't have to do the whole 2 or 3 miles. We can keep it going, lapping. I don't know. That's the best I can come up with. But I'm still thinking on it. So I'll give you whatever I can come up with.
Everyone brainstorm on it. Let's figure out how to, ways to make straight lines over distance horizontally, and maybe we'll come up with something. That's all.
Yeah, and if I'm gonna do it, I'm gonna do physical. That's gonna be the main measure baseline to measure against. The water level is a physical line of some type. I know other people are using different things, and that's great. Auto level, whatever. That's fine, but I think a physical just takes all the excuses out of the equation, or a lot of them at least.
I really like how Bev calls them out, because it is definitely two different things. When you're speaking of two models, when you're speaking of the ground dropping away from you, like 8 inches per mile squared, and having the hump in the middle, that is most certainly two different things. They can adjust the angles all they want, but it's different, because that means you're facing in two different directions. If you're facing straight forward, or are you facing down, leaving the middle a hump, so I like how Bev calls them out on that. And Bev's test, to me, man, if done, meticulously enough, it is proof enough. But yeah, we know that that's not gonna. I don't know. I like hearing him squirm, though, man.
Bev's test is solid. I went after the show last night. I went to Bev's, and they ran me through it, and the shit's solid. What they're gonna do. So I still would like to have other ways, though. Something physical, definitely. A tangible physical, whether it be a line on a wall, whether we draw the line or whatever.
We had kicked around the idea of printing something off, print off the straight line on paper, and somehow.
I remember that. Yeah.
Somehow, printing something else on the piece of paper that you align the pieces of paper overlapping on each other.
And then tape them to, or not tape them, but
the idea I had,
adhere them to a wall.
Yeah.
That's the idea I had with the styrofoam. They're real light and easy to carry, and they're solid as shit, dude. You could hardly break one, man. You'd be surprised how light and sturdy these 4x8 sheets of styrofoam are. And so if we got about 20 of them, right, and draw a straight line, pretty much, and then just lay them all 10 out and just keep rotating 5 of them from the back. And or you just put the money up and mount a whole shitload of them. It'd get costly, but to me, it's the same if you keep stacking them as putting new ones on, and just keep transferring the line over distance. And if we were to go collectively and had a bunch of people, if we were to go like 10 miles or 5 miles even, it'd be so apparent. We'd know for sure whether it was dropping away or going straight. After about 2.5 miles, it'd become pretty damn obvious. But 5 miles, it'd be not much you could argue with.
Well, we need to go in each direction from the starting point, so that any error as attributed to the line being tilted, not perfectly parallel to the ground, evens out on both sides of the middle point.
You got to make it no, you're right. You have to start your line, make it level in the middle, and then you go out both ways. You can't just go one way.
Yeah.
I got an idea for you guys.
Let's hear it.
Would a canal work for you guys?
Sure. I mean, the wall of a. Let's hear the idea.
Okay.
Yes, a canal works.
So
What do you got?
you find the canal. You said a few miles long would do, right? 2-3 miles.
Depending on how straight we can make a line, you might only need a few 500-600 feet. But yeah.
Well, that should be easy then. So what you do is you find the canal with a wall, right?
Yeah.
You hang a plumb. You mark it.
Yeah.
You move it down. You hang it. You mark it. You move it down, and you got a straight line all the way down. Keep it straight length on the cord, and there's your straight line.
Wait, you hang a plumb line. So this has no, because the Globers are going to say that the plumb lines are. So say it again exactly what you want to do.
You find the canal with a wall, right? You said you want to draw a straight line, right?
Yes.
So you find the canal with a wall, you hang a plumb line, and you mark it at the bottom where it evens out, right? Move it along.
Hold on, mark it how?
You mark it. You where the tip is, right? You're exactly parallel there, right? Aren't you perpendicular? If you
you can make a perpendicular off a plumb, but they're going to say that the plumb changes and it's going with the curve of Earth, though. That's the thing.
You think they're going to claim that?
You know what I'm saying? Yeah. Well, yeah, that's their that's their main claim is that plumb lines aren't parallel. That has to be on their model. They have to have that.
Here's what they say, Montreal. When we're back shooting and then front shooting, so technically, if you're in the middle and you shoot 100 feet forward and 100 feet behind, them two spots are exact, right? But then when you move up to the next one, they say that you're gradually tilting downward.
I forgot their magic. I forgot they're thinking to the center. I forgot about their magic. Yeah.
That's one of the.
They say you're shooting line segments around the globe, but yet you only get 1 degree of curve at 69 miles.
We're not hating though. Everyone keep thinking of stuff. We don't have to fight about it. Just brainstorm ideas, and we'll give our constructive criticism on them. That's all.
To be honest with you guys, I think Data has the best idea.
The drone thing.
The line, but it's damn expensive.
That's a good idea, man. If I'm to understand it correctly, if what he's talking about is going up and then going and looking out, I think what he was trying to describe in my mind is that looking out, you could see about 3 to 6 miles or whatever side to side. And if we could get two known marks of known elevation, we could see if it's a straight line in between them or if there's a hump in between them. If that's what he was explaining. So if you're listening, Data, come in and elaborate on that.
Are you talking about?
That is a pretty solid idea.
Are you talking about his drone idea, SE, or something different?
Yeah, the drone idea, the line of sight, yeah.
The only thing I don't like about that is you have this reliance on all. It's kind of the same as optical, because you're relying on these sensors, and it'd be so easy for someone to say, well, those sensors only have a margin of error of 0.1 millimeter, and that adds up to 6 feet over 3 miles or some shit like that.
Yeah, they'll find some wiggle room out of it for sure. Like anything we come up with, they're gonna find some wiggle room. Yeah, but I kind of like that idea because once you establish the first drone, right, then all the rest of the drones are like slave. Think of it like master slave, right?
Yeah,
they're aligning to that first drone. You know what I'm saying? But I know where you're coming from, Brandon. They're gonna say, well, how detailed are the sensors and blah blah blah. I get what you're saying.
Right.
Well, one of the ways I liked was to have picture the shape of a spirit level, thin, long, rectangular object. You get three objects shaped like a spirit level. You have them precision machined, so that they're pretty much perfect. Then you just put two side to side and put one underneath it. And then you draw a line, or you can make dots, whatever. It doesn't have to be a line. You could just make dots, draw a line, whatever. Then you put one of them, you shift them over one by one and keep progressing your line like that. That would have an error mark.
Yeah.
That could
we
be
have
one of the
20-foot aluminum rods, Jeremy. Like 20-foot aluminum rods, and they're machined and they're super straight, and for getting concrete flat. And just take unless we could find one longer, we could just take on wherever we're drawing the line and draw half of it. You know, go 10 or just draw 20-foot line, and then just move up 10 foot. You know, and trace that line. You know, where it keeps progressively sticking out 10 foot at a time, where you know you're maintaining an exact line. Something like that. But string lines are accurate as shit over a close distance. So I thought of the idea of overlapping string lines, and even tried it. But boy, it's some work, dude. It's going to take some help.
Yeah, for sure, it's going to be some work. There was this, not string, but this wire. Let me bring that up. I don't know if I've showed this to you guys before, but there was some wire that I found that they use for laying out long factories. Actually, there's a link in here, and they use it rather than any laser or optical stuff because it's more accurate. And it's only got like a, what was it, like 0.2 millimeter or 2 millimeter? It's either 0.2 or 2 millimeter error over 300 feet. Still an error, but if you take that into account, I think you can take that into account.
If we could take it into account, that'd be perfect. But the problem is, it's 2 millimeters over 300 feet.
Brandon,
Yeah. What's up, Jeremy?
Brandon, I just sent you a DM with the 3 rectangular precision machined objects. Hold on, the picture's taking a while to load.
Okay.
Put that up on the big screen, and then I'll show you how you would do it. It's coming through any second. Hold on.
All right.
You put your 3 objects on the wall. You have 2. You got it?
Let me bring it up in a minute. Let me just finish telling you guys about this real quick. Oh, that's okay. Yeah, I'm just trying to find out where it's this carbon fiber wire. I'm trying to find out. I know that there was somewhere in here that said what the error was, and it was really minor. 130 meters long. Oh well, that's okay. I'll bring up your thing, Jeremy. I'll look through that in a minute. Just got to figure out a way to take the error into account.
Yeah, so here's my idea. All those lines are precision machined, the spirit level shaped metal objects. You would put them on the wall. You would start off, you would put them on the wall just like that. Draw your line across B, or A and B, whatever. Then you would hold B there. You hold B right there. You don't let B move. You replace A on the side of it. Put the C under them both again, and then continue your line or dots or whatever you're going to make for your horizontal plane. You know what I mean? And you can just keep progressing that way.
I see exactly what you're saying.
Next time you would hold A there and move B over to the right side, and then move C under him. You know what I'm saying?
Yeah, it's kind of like the rectilinear experiment contraption that they use, but they were using sight angles too for that. Have you ever seen that, Jeremy? The rectilinear.
Sorry, what was it?
It was called the rectilinear experiment. Those guys who did well, I can't remember their name.
The guys that found concave Earth. Did it end up being concave or?
Yeah, they talked about it, but these were the guys who did the mine experiments back at the end of the 19th century, beginning of the 20th century.
I heard about that, man. Yeah. Also, man, and my wife pointed this out. If you look at the high, like even the Mage footage, okay, you could look for all this left-right drop all you want, but if you look out in the distance, it does not look. It kind of looks like it's coming up. I'm not talking about the perspective. It looks like the ground is slightly raising up a little bit, man. In my opinion, if you look at it hard enough,
settle down. We're not on concave Earth. We're not on concave Earth. Settle down, Brian.
Well, then flat at least, right? not. How about this? Not absolutely not curving away from us. Straight ahead.
We got enough problems without concave Earth.
I was trying to think of something like this too, where you look through like a long tube and you can only see, you could calculate how much of an area, how far away you could see. Let's say you stood 50 feet behind a long tube and you looked through the long tube, you could calculate the area that you see through that long tube, and then you could line something else up down there and say, okay, I know it's within this area because I'm looking through this long tube and I see it on the other side downfield, so it has to be in this position. But I couldn't come up with anything on that yet.
On the flip side of this, on the flip side of trying to make a straight line, we could try to make something that drops 8 inches per mile and then measure the water against that. You know what I'm saying?
Yeah. Yeah, here it is, man. Say that last thing one more time, Jeremy. Sorry, I got excited.
Oh, on the flip side of making a straight line, we can make something that drops 8 inches per mile. Which I don't know if that would be more or less difficult or what, but it's an option.
Well, that's an interesting idea. Build in the curvature.
That would work. Yeah, that would work for us to compare it to, because then we put the water level or whatever, we fill it with water, and then we'll see, is the water fucking flowing out of it, or
you may need a shovel, or you may need a shovel or a snorkel.
All right, do you see these pictures? This is what these guys were doing. They had this contraption, and I think they called it the rectilinear. Here, I'll make it bigger. But it was like these connecting sections. They'd line up one, kind of like you're talking about, but they were using a physical object. They'd line up one, it perfectly attaches to the next one. Then they'd piggyback the one behind it, line that one up. It attaches to the next one. And they went for quite a ways. I can't remember exactly how far. But they went a ways on a beach. And then at the end they said, the Earth's concave.
Yeah.
I'll be perfectly honest. When I went but I only went not quite a mile, just doing real meticulous shots and back shooting and stuff. I was doing side shots and lining up. I want to do it where I line up 5 stakes along the beach and shoot all 5 of them, and then move the back 2 to the front and just keep working my way down. But I only did it with 3, and it seemed like it was coming up, the mark was getting slightly lower. But that's well within the margin of error, so I can't make that claim. But you got to leave a little bit of room for that possibility.
Hey, Brandon,
as far
want to laugh?
Yeah.
I asked the surveyor exactly what I was trying to tell you guys before with the plumb line. I asked the surveyor if we were to do that, a real surveyor in Montreal, and he told me that line would go straight out into space. How do you like that?
Yeah. I remember you telling us about that. Got a question here from B-Ball for Life. He sent us a $5 super chat. Thanks, B-Ball. Off-topic question for Brian Leakey. Does the ISS change in angular size?
It's a little spot of light when you first see it. Well, let's just say this: if it's supposed to change in angular size, and I can see it over 2,000 miles from one coast clear across the next, can you even have this conversation? With a serious conversation. If I'm supposed to see something the size of a football field from one side of the United States to another, it's a joke right on its face.
We killed them guys in Jose's earlier. Shouts out to Rocky.
Yeah, that was funny. And Jose's, the topic was they were all talking about how flat earthers and globe skeptics don't think outside the box.
I heard that. Yeah.
Shout out Jeremy, man. We were killing them all day long.
When they have a box where when a ship goes over a horizon, that's Earth curve in their box. They can't come out of that box. When they have a model of the sky, they have a model of how the sky works, what the sky is, that's in their box. They don't come out of that box.
They're all boxed in.
And the sun being 93 million miles away, they can't come out of that box, man. And the moon being 240,000 miles away, they're boxed in so much shit. You named a good couple, but there's so many more, dude. They're totally boxed in, man.
They're awfully scared of flat surfaces for people who live their whole lives inside of boxes.
The spherical box.
They're inside boxes, inside other boxes. They're like Chinese nesting dolls.
If you guys want to hear the double speak, shout out Jose. Watch his show today, and you're gonna freak out.
I give a shout out to Jose, man. He comes up with some good topics, man, to get it going. I'll give him a shout out. I think that channel and this channel are like the 2 best ones yet that I've found with the honest, fair debate. Speaking of which, where's all our competition tonight?
They're afraid to come in here, bro. We go into their jungle, but they're afraid to come into our jungle. I don't know why yet.
Hey, listen, is there any other group out there besides Nathan, Jose and us. Is there anybody else doing this?
That's doing flat Earth in debate. And
Yeah,
stuff?
yeah. It's absolutely crazy. Like I would think that like somebody from Brazil or somebody from the Ukraine. Like why are there other people doing this?
You got guys like Fight the Flat Earth that goes against these nameless, these absolutely nameless flat earthers that we've never heard about. That weren't, I'm not even sure if those are.
They do ridicule, Jeremy. They don't do debate.
They're obviously, they're obviously real people, but I'm not even sure that they're actual flat earthers. I've never heard of most of the people that fight the flat earth debates. I've never heard of any of them.
They purposely go and look for pose.
Something,
yeah.
Because they ain't he ain't. I mean, aside from the few times where Chemo or Percentage or one of us will go on Fight the Flat Earth. Other than that, most of the guys that he debates are just. I never heard of them before. Never seen them. Never heard of them. Nothing.
I don't go on Facebook too much, but I heard he gets a lot of people from Facebook.
I heard the same thing, Brandon. I heard he goes out fishing for prey on Facebook. That's what I heard as well.
Yeah, and he sends his minions around and goes, you should go talk to Fight the Flat Earth. He's looking for flat earthers to talk to. He's purposely looking for weak debate opponents, in my opinion.
Well, if Fight the Flat Earth ever gets an Adderall prescription, I'll go on his show.
Don't go on when he has another person on, though. That's another thing that he does is it's set up to ridicule you, and it's just, I understand why people go on there. Like, who was it that was on not too long ago? Chemo and Percentage did a good job. But
Percentage is the fucking man, eh?
They had two people, and I was happy to see that they had two people because they'll gang up on you, and you just have no hope of
whoever that goon. My bad.
Brainy Beaver, or Brainery, something like that.
Whatever that goon is that's playing with little kids' toys on the camera.
You
know what I'm talking about? He's playing with little dolls, or what's he got? A little doll collection or something? I don't know what he's got going on, but that guy.
Yeah.
I don't even watch that show. Period.
Yeah, I check it out when somebody on there that I know, but other than that, I don't pay it too much
attention.
Yeah,
like I think Gleam went on, or if somebody of our guys, I'll watch it too. Yeah, but other than that, forget it.
We had another super chat from Esteban Ilabaca. Thank you, Esteban. What about doing a triangulation between places at known elevation and distance? You can measure yourself. Just measure the angles. If they add 180, it's flat. It sounds like you're describing an optical type measurement. Esteban.
Yeah, that's just it, man. Like,
well, hold on. This guy thinks a triangle.
Good.
My bad. Go ahead, Brian. Go ahead.
No, you go ahead. You go ahead. I got a point after that.
Is this guy talking about making a triangle and he thinks there's going to be more than 180 degrees in it?
Yes. Yeah.
That's just another way of saying. That's another way of saying the ground is dropping away from you. You can call it a triangle, call it what you call it, drop, call it whatever you want. It's crap. Okay, we see that there's things down in the distance. Okay, we're attributing that to the atmosphere. Okay, things being down in the distance. So you're going to get your triangle with more than 180 degrees, which doesn't make sense because it ain't even no longer a triangle. But it's still we acknowledge things drop down in the distance. Okay, but we acknowledge that they vary and drop constantly, and sometimes they don't drop at all. Okay, that's something they won't come outside of the box and acknowledge.
Yeah, and to add to that, their model of how that works, how perspective works, and their use of trigonometry, straight trigonometry, this is my opinion, is an unvalidated assumption. So they're relying on an unvalidated assumption that that's how perspective works at distance, that the horizon always rises to eye level on a flat plane and can only fall from eye level on a sphere, and that objects will never go below the point you see them at if they're eye level. I have not seen those validated at long distance, and seeing in perspective is a lot different than Euclidean geometry. We know those things work in Euclidean geometry, but when you start adding the side angles in there and making these assumptions about perspective, that's the part that hasn't been validated. So the rest of your logic that follows is suspect, in my opinion. Plus all the refraction and shit just nullifies the whole thing anyway, but...
thought
does anybody
shut up
know
the plain truth,
over?
man. I thought. Go ahead.
Does anybody know over what distance you would have to measure a triangle for it to become more than 180 degrees?
Yeah, you cannot. At least this answer. You cannot be out. Hold on. You cannot be out of line of sight. You have to be able to see each other.
You will never measure a triangle having more than 180 degrees. That is absolutely impossible and ridiculous.
Right, it's impossible. You can't do it.
A triangle will never have...
It's a trick. They're attempting to get you to agree to a triangle in 2D space, and then they change it to 3D space and say, see, more than 180 degrees. That's all it is.
I don't care how many spaces you want to use. You could use 5D space. You're not going to get a triangle more than 180 degrees.
I'm just explaining what the trick is. That's
no
all
doubt.
it is.
I know.
Yeah, so even if we pegged out a triangle on a 100 square mile salt flat, you like with 100 miles of cord and could pull it tight, that triangle would still only have 180 degrees.
Well,
on certain days you could show more than 180 on certain days. I think. But Travis had a great.
Then it wouldn't be a triangle
point,
anymore.
man. Yeah, Travis had a great point. Like with the Superior Mirage. Like the thing is, it's not just the thing coming up. It's mainly the medium, the horizon dropping down. That got me thinking like crazy, man. That was a hell of a good point there.
The thing the Globers are trying to do, it's called a spherical triangle. It has a name. It begins with an R. It's hard to say. I don't even know how to say it. But that's the triangle they're talking about, a spherical geometry or something. Because no triangle is going to have more than 180 degrees. And also, when you start to curve you can't take an angle off a curved line. You need a straight line to get the angle off of. Because if the line is
here's how they do
it.
They do it like this, Jeremy. They say you draw a line, a zenith, right above your head. You call that the 90-degree angle, okay? And then you shoot out in the distance, okay? And at 0 degrees. So they're saying if you go out at 0 degrees, that should be 180 degrees. But if it drops below if it drops below like 1 second, 1 arc second, then they call that more than 180 degrees, which it technically is. But it's optics, man. It's just a fancier way of saying the ground curves down. It's a fancier way of calling drop. That's all it is, man.
We have another super chat from B-Ball for Life. This is aimed at some of the panelists, I believe. It's funny how as soon as we started talking about something which was impossible on flat Earth, all the flat earthers left Jose's and went silent.
Earthquakes on flat Earth. Yeah.
Go ahead, Jeremy.
They were asking us how earthquakes happen on flat Earth. I asked them how it happens on a globe. They said it was from tectonic plate slipping. I told them that's how it happens on flat Earth. Tectonic plate slipping. Boom. What's the problem?
Yeah, I've done the same thing, Jeremy. Why can't you have tectonic plates? Something in the ground moves. I mean, it's just not that hard to figure out.
He might have been talking about the magma, actually. I don't know what he was. I came to come on here. I didn't.
I know what he's talking about. I think I know what he's talking about. First of all, we were schooling them all day on the Kola borehole. I even named it. Today is the Kola Deep Borehole Day. Thank you, guys. You made me laugh all day long, man. But they were talking about, I think, Jeremy, besides the double speak they were talking about the clouds illuminating. That's the last thing we're talking about. And I told them, look, guys, I got to go. I'm going on to Brandon's. I think that's...
Oh, I left before that. I left way before that.
Am I right, B-Ball? The cloud thing?
Make him super chat it.
Yeah, super chat your answer, B-Ball. Hey,
let us know what it is so we can discuss it real quick and tell you how it's either nonsense and it's retarded and doesn't need to happen on a flat Earth, or how it could totally happen on a flat Earth. That way we don't leave you in the dark there, buddy.
Yeah, we don't want you to worry all night.
I'm going to be respectful to you.
B-Ball,
no one's going to bite.
He hasn't stopped in for a while, has he? What's up, B-Ball? You don't like us no more or what, man? He's not answering. I don't know why I paused like he was going to answer. We got another super chat. Awakened Narrative, $4.99. Presuppositions and pseudoscience. Amen to that. That is what it is. That's what we're fighting, in my opinion.
Brandon, can I just do a big shout out for your YouTube chat to Ian Adams? He's there every night you go live, and he's hitting back on the werewolves and the trolls every night you go live. Big shout out to Ian Adams. Thank you very much.
He is. We got some excellent regulars. Ian's one of them. Excellent regulars in chat who fight the trolls constantly. I've given a few of them some wrenches. So that we can take out the trash that doesn't want to do anything but come in and say flat earthers are stupid and that kind of thing. I think we're done with that. I think we've had enough of that.
Our boy. Oh, my bad. Go ahead.
We don't need to take that kind of abuse. If you want to argue with us about the science, if you want to have a constructive, funny conversation, you want to joke back and forth, cool. We don't need that kind of negativity. No reason for it.
That's the real trenches right there, the chat. Because I used to be in 24/7 in the chat, and poof, those chat trolls are something fierce, man. That's the deep trenches right there. Shouts out to Ian.
Hell yeah.
And all the rest of you.
They're never ending, are they, Jeremy?
It never stops, bro. I was in 24/7 for like a year before I even came on voice, and oh my god, the amount of trolls, it's never ends. It's like a flood.
Yep. It's almost like it's their job. Another super chat, Esteban Ilabaca. Thanks, Esteban. Everything said about the triangulation arc measurement has nothing to do with the actual method used. Just read up on it, then try to debunk it. All right, fair enough. Maybe we'll take a closer look at that one of these days, Esteban. And Glenn's Maelstrom. Thanks for the super chat, Esteban. Glenn's Maelstrom, 714. Good number. I like that number. Good to see some new blood. Yeah, good to see you joining the chat and joining the audience there, Glenn. Thank you, man. Then we had another one that just came in, and that was from my Nelson is covering it. Hold on just a second, and I'll read it to you guys. And that is from Taking Back Eden FE. Duh. Thanks, Taking Back Eden. Any of the panelists watched The Principle? Oh, yeah, for sure. I think we've probably all seen The Principle.
Oh, yeah. That was beauty in the making. The evil of Axis. The Axis, sorry, I got it backwards. The Axis of Evil. That was beautiful.
Yeah, that was
that a movie? I didn't see that.
Well, let me bring it up on the screen. It's a really interesting documentary. I can't remember the guy's name who made it. Maybe you do, SE, but we'll see it in a minute anyway.
Sorry, I don't remember.
I think it's Robert Sungenis. Wasn't it Robert Sungenis?
Yeah, it was Robert Sungenis.
Yeah, I think so.
That's got one of the best quotes from Michio Kaku in it. You guys know what it is. I can't recite it word for word, but
yeah, in cosmology, we're off by so much. 1 with 100, 10 with 120 zeros. That one?
Yeah,
I have a meme on that one. That one is one of my all-time favorites.
So here's a little hint that it's worth watching. This is a Variety article. Oh, come on, stupid ads. Film review, The Principle, a professionally polished, insidiously coy documentary that seeks to debunk the Copernican principle. And after it came out, a lot of these guys, I think he was one of them, Michio Kaku, and the narrator, who is Janeway from Star Trek, I believe.
Yeah.
Was complaining, they tricked me, because he's not a heliocentrist, he's a geocentrist, this Robert Sungenis. And they tricked me. I didn't know it was so controversial and all this crap, but it's really worth watching. It goes through the history of how the Copernican model was kind of put together and some different history that you may not be aware of if you haven't seen it or haven't studied it in detail. It's really worth watching, so I highly recommend it. Like I said, he's a geocentrist, but at least he's thinking outside the mainstream. And it's good. It's interesting documentary. Yeah, good suggestion. Taking Back Eden.
I mean, I don't understand what the problem was. I didn't see any trickery. He asked them questions. They answered the questions. Where's the trickery?
Yeah,
Or how
no
is it
kidding.
insidious?
No kidding.
I think after they saw what they actually said, Michio Kaku said, shit, did I really say that? That we're wrong by that much? Wait a minute, let me backtrack.
Yeah, he probably got a couple phone calls like, hey, why the hell did you say this?
Was there did they hand Michio Kaku a script and say, hey, read this off? Or did they just ask him his, honest opinion or thoughts on the subject?
No, he was just they were asking him questions and he was answering them. You got to see it. You got to see
That's
it.
what I mean. I don't know. I've seen it. I don't know what the insidious part was. That seemed like a very harsh and unfair review.
Yeah, I agree with you, Jeremy. I mean, you ask a question, the guy answers sincerely. I mean, well, I don't get it either.
Exactly. There's some.
That's right. You know what?
Let me ask you a question real quick. So, are you saying that the Michio Kaku's quote comes from being interviewed by Robert Dennis?
You're flipping.
I think you asked if the quote comes from being interviewed by Robert Sungenis, and the answer is
yes.
He does say that quote in the movie. I don't know if that's the only time he said it, but he definitely says it in the film. All right. Well,
Michio Kaku has another great quote. Hold on, Michio Kaku has another great quote that Chuck was saying from Oakley's. Can recite word for word. I forget what it is though, but this guy, he's my favorite astrophysicist. This guy, or whatever the fuck he does, theoretical astrophysicist,
storyteller.
Oh yeah, I love this guy. This guy.
He's a science educator.
I know you're going off soon. What are you going to talk about?
He's almost as good as Bill Nye, the science guy. He's my all-time favorite.
Let's take a look at this and then wrap it up. So B-Ball, who has generously donated to the show tonight, put a couple things in general. And he asked the question that he's probably asked many times before and been given an answer many times before. Why are the bottoms of the higher clouds illuminated, but not the lower clouds?
You see, Jeremy, I told you that's what it was.
I've answered this fucking question so many times. It's ridiculous. Look at where the sun is. The cloud. If you were standing at the cloud, you would see the sun at that angle. That's why the sun's shining on them.
Yeah. One other thing about that, B-Ball. Go back a few episodes, and I pointed out to Rumpus, and in the end, he agreed with me after doing the math that if the Earth curve is only 1 degree per 69 miles, it wouldn't have an impact. You wouldn't have upward shadows in buildings or the sun on clouds. It's not enough, okay, to make a difference. There has to be some perspective. Now, he didn't submit to that. I'm not saying he said that but he said that, yeah, with the 1 degree per 69 miles, then yeah, that do the math. How many degrees would you have to have if it's only a few thousand foot for 1 degree? So look, the sun lights local clouds, man. The sun doesn't act like everyday run of the mill light. Okay, if it was 93 million miles away, it should brighten all the clouds. Okay, not just the clouds near to it or some of them in its path at the bottom. It should light up the whole horizon equally, okay? But that's not what happened in the moon either. Yeah, so
and the cloud,
that's what we're trying to figure out, brother.
You see the bottom of the cloud, it's black, okay? It's not illuminated. That's water for me. Like,
I just remembered Michio Kaku's other quote. It goes something like, nobody in my field uses...
Black. Rain clouds are black, aren't they? Why are rain clouds black and sunny clouds are white? That's another question.
Yeah, Michio Kaku, just real quick, Michio Kaku's other quote was, no one in my field uses a scientific method. We do more of a fly by the seat of our pants kind of thing. I can't recite it word for word, but...
Yeah, that's it, bro. Great. That's it. Yeah.
Chuck
and I posted the other one, by the way, in general.
Yeah, I saw it.
This guy is an abject clown, and he's a top physicist. A top physicist, man. Wow.
Here, let me read it. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. we're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120th. That is a 1 with 120 zeros after it. That is the largest mismatch between theory and experiment in the history of science. Michio Kaku interview the principal. And it shows the number. That's a long number to be off by.
You see how many zeros that is, bro?
That's a lot of zeros.
They make excuses. I post this up and they laugh at me. Oh, you didn't understand what that means. You took them out of context. Yeah, sure, dude.
Of course.
Sure. Oh, anytime we get one of these clowns saying something crazy, we're always taking it out of context. So when it'll be this very simple, remember the Andrea Ghez thing? Something very simple, and they always say it's out of context.
Yeah.
If you scale that down, if you scale that way down, like instead of talking about the universe, and you scale it down to local, and that's would probably be 10 to 10 zeros behind it of how big Venus is compared to the Earth in reality. It's not the same size. If it is something tangible, it's probably like 10 to the 10th smaller than the Earth or something, or some number like that.
Probably. All right, we got one more super chat from Awakened Narrative again. Thanks, man. Pseudoscience is my biatch, he says.
That was another thing B-Ball said. B-Ball earlier, B-Ball said science keeps changing. It's forever changing. It's wrong, and it fixes and corrects itself. That's not what science. Pseudoscience does that. Yeah. Real science doesn't change. You get a cause and an effect. You get a theory, and it's validated, and it's not going to change. You know why? Because we fucking validated it. Your pseudoscience bullshit, on the other hand, can't be validated. So it's always fucking changing. That's all.
And if you want an example of that, the ultraviolet catastrophe, the black body radiation. Okay, it's like if you heat up a black body to like 700 degrees or what, something like that, 700 Celsius, and it starts glowing red. And then you add energy, and it starts glowing yellow, and then or orange, and then yellow, and then green, blue, and then white. And then instead of add more energy to get the ultraviolet, you don't. And they admitted, this is one case where science admitted that they that the math was wrong, their theory was wrong, and they come up with Planck's law he admitted that he just made up numbers until it fit. And quantum physics said that. I'm going to have to explain this later. I'm getting some background. Sorry, guys.
You know, if you want to really learn how to apply the scientific method, your shower curtains are a good start. Why they move when you're in the shower trying to sing, they all come onto your legs and everything while the water's flowing. Everyone will assume 1,000 different reasons why this is happening. And there's only really one. So, you know, when you're doing science, true empirical science, where you're doing comparisons of a fixed variable and a known variable and your fixed variable, well, you're keeping ratios and proportions constant. That's why we have these simple formulas that A equals B over C. If you vary any one of them, the others can only vary by as much as is permitted by the proportions that you have. If not, you have like 120 volts to start, but at the end you wind up with 200 and some, or 300 or whatever. It wouldn't balance. Energy in, energy out type of thing. You know,
I agree with you too, Jimbo. I agree about you're talking about the water vapor. You know, the more I've thought about that, the more I see, you know, it follows the water vapor from what I could see, and probably past that, follows the gradient as you go up.
I believe so.
It might have some more to do with temperature, you know, but I believe that.
And I've kept this under the belt for a long, long time about the stars. But you want a little shocker? Everyone?
Sure.
You've seen bubbles.
Yeah, always.
You've looked down at a sink full of different sized bubbles with a light on top, making a little specular highlight on the different sized bubbles?
Yeah. I know what you're talking about, yeah.
Now, Imagine above us whatever the so-called dome or rakia is, if it had some of those bubbles. What would be the result? Specular highlights, as we call them in the arts, exactly like we see parading around us overhead, dancing heel to toe.
Interesting.
I got another question. Has anybody ever seen star trails? Has anybody ever seen 90 degrees Sigma or Sigma Octantis? Or,
different size bubbles.
There's no star in the center of the.
We'll give different size highlights, bigger and smaller stars. Just saying, it's a possibility.
I'd like to point this out. Yeah, that's a hell of a, that's something to look into there too, Jimbo. I'd like to point this out. When you look at the northern and the southern star trails, they don't quite look the same, man. The southern star trails look different. It looks more like perspective, looking off in the distance, man. But even if it ain't that, man, I've never seen anything south of like 50 or 45 degrees, man. It's like, and that goes for the North Pole too. Has anybody ever seen a zenith with Polaris in a zenith?
No.
How are they even claiming these rotations when they can't even show a zenith, or even where it's even up in the sky? It's always on the horizon, way off in the distance, man. And
I think
for
a while.
Yeah, go ahead.
I was going to say, I think a while ago, Veach showed me a star trails from 90 degrees. So I mean, I don't know. I never took it any farther, so I didn't even.
Okay, now if you look up, I'm gonna cut and clip and highlight this video. It's a little piece of one of the star trails I did. He showed how Orion's belt. Okay, when you're looking at it from the far north down toward the southern hemisphere, when you're looking at it from a distance and it's on the horizon, it makes a small loop. It makes a big loop on your local horizon. But way off in the distance, it comes up above the ground, and then it comes into view, whatever, and then it drops right back down, basically. In other words, where even it's all optic. It could be perspective. How could Orion's belt make a smaller loop? If that's what it really, if it's I don't know. It's almost got to be perspective. How could it be physical? If it's making a smaller loop, if we're seeing universal distances, it'd be the same size loop no matter where it was on the horizon, no matter what your position. I'll show you. Know what? Yeah, it's got to be, man. It's got to be.
It is. If you think about it, anytime you face south from the north, you're going to get a perspective view instead of a. Well, if you face north, you're going to get kind of a view of it, but if you face south. Okay, I don't know how to explain this, but you are right. The far stars, think of it as far stars are always going to be low in the sky, right? And then close stars will be high in the sky. So when you get your little small loop that you were just talking about with Orion's belt, if you're like farther north, it's because of perspective. It's farther away, and it's just going to make this little tiny thing from one horizon to another horizon, but it's going to be a little short piece, right? And then the next closest stars will be a little bit higher. The next closest ones will be a little higher, and they'll make it look like a star trail going across the sky.
See,
and then with their wide-angle lenses, they'll twist it. Go ahead.
They made these. I'm with you. I understand exactly what you're saying. They made these videos. They weren't thinking nothing about the shape of the Earth. They're just calling what they see. Okay, and if they're seeing Orion's belt from the drastic north, like Canada or whatever, on the horizon, if they're seeing it make a smaller loop, it's not supposed to do that. But they're not thinking in terms of the debate. They're calling it how they see it. And if it's making a smaller loop, that alone is a model killer. If you ask me, if we're seeing, if we're the ones rotating and the stars are set, then it shouldn't matter. The loop shouldn't be smaller. And I'm gonna make a very short video that everybody could appreciate and watch for just a couple minutes, showing that Orion's making a super small loop from this one spot. I'm pretty sure it was in Canada or Alaska, and then showing it closer toward the equator, making a big loop. Okay, if it's universal light and we're seeing it from umpty million light years away, the size of the loop should be consistent.
Well, that is a very interesting, Brian. I'd be very interested in that because perspective should not be impacting it at all. Right?
Not if they're hundreds of trillions of fucking miles or light years away or whatever. Hundreds of light years away.
The circle should be
You know
the
what? I
same
just
amount
remembered
of
I didn't put that
sky
part.
at the North Pole as it is at the 80 degrees at 70, 60. Yeah.
Man, I want to choke myself out. I did not put that part in the video, but I know where I found it. It's still going to take me a minute. So it's something
It's
I might
going
be
in
going
your
to do
file
tomorrow or the next day. But golly, I wish I'd have put that in the video, but the video was already starting to get long, and it was just about Orion, how we should not see it 6 months out of the year. It's a winter constellation, and I showed multiple sites, teachers, NASA websites, quote NASA websites, and the picture of the day or the sky, the night sky, the constellation of the day or whatever, showing Orion in the middle of June, and then in July and May, all through the winter. I mean, just in different spots on Earth, and it's not supposed to be the case. And I've still yet to get a satisfactory response.
Yeah,
to that, except for Bob saying no, it doesn't.
Say if you're in America, you should be able to see it for give or take half the year. Another half of the year, you shouldn't be able to see it at all because it would be in the daytime sky. If the sky works like they say, yeah.
Well, hey guys, this is a good conversation, but it's already after 8, so we're gonna do final thoughts, and then I'll record the after show. But if you guys can hang out if you want. Here, I'll go first with my final thoughts. Thank you to the panel. Really good discussion tonight. Really appreciated it. Thanks, Babs, for bringing in your demonstration and your arguments, getting everybody riled up. Appreciate you coming in. And thanks to the audience. All right. Yeah, that's it. Thank you. That's my final thoughts. Brian, you go ahead.
Yeah, I'll be honest, and I'll say to B-Ball, there are some good questions. And if I was arguing for the globe, y'all got plenty of people arguing for the globe, man. I try and think outside the box. Shout out. But there are some fair questions, man. The flat Earth has some splaining to do. That's why we're here, man. We're trying to make sense of the things, and we're trying to get past the kinks in the globe model, trying to point them out to y'all so y'all could start, just open up your imagination, start thinking, what if, there's a good chance that it's a plane, okay, and that the light is playing tricks on us in the distance, bending down, whatever you want to call it. Either the ground's bending or the light's bending. In my opinion, something's bending off in the distance, but it's not reliable, in my opinion also. So there's nothing wrong with questioning everything, man, and just philosophizing and trying to come up with tests and experiments we can all do, man. And there's nothing wrong with that, man. But it's a great debate, man, and I think it should spread, man. I think there should be more and more panels like this. But I'm gonna do my best to keep it going. Thanks.
Yeah, thanks, Brian. Hopefully we can keep the show going and we don't get caught up in any of this censorship that they're doing. So far, this channel's been lucky. Gadget.
Hello. Yeah, just a big shout out to Ian Adams again tonight. He did a great job in the YouTube chat. He really deserves a wrench there, Brandon. And another thing, a topic I'd like to talk about, probably in one of your future shows, is jets in space. How do we propulse ourselves in space? The way submarines go against water, boats go against water, cars go against friction, airplanes go against air. How do we move in space? I'd love to have a topic, talk about that one night. That's it.
Yeah, sure thing. We can do that. Gary. We'll come back. Travis.
Yeah, great show, Brandon. Gadget asked a question about the translucence of the clouds. I've noticed that when I take pictures a lot, I'll look up and I'll see a lot of clouds are just pure white, but there are some that have a shadow, and they're all in the same area. The only thing I can answer is that those clouds that have a shadow are more dense so that the light is not penetrating them. And he was asking why storm clouds are dark. I would just say that there's a tremendous density in them so that the light's not making it through the cloud. But great show.
Cool. Thank you, Travis. Jeremy.
All right. I just want to say Bev's test is good, but I want us to think of more ways to make a horizontal line. We can't. I don't want to just rely on one single way to do it. So everyone brainstorm. All we need to do is make a horizontal line, guys. Should be easy, but it's not. But everyone brainstorm on it. We'll put our heads together and see what we can come up with. That's all.
Cool. Thanks, Jeremy. Jimbo is deafened. Thanks, Jimbo, for joining the panel. Howard.
Yeah, good civil conversation over diverse topics. Thanks for the show.
Thank you for joining. SE Montreal.
Yes, sir. Another great show, Brandon. Congrats. It was very interesting tonight. I enjoyed it. Peace out, everybody.
Thanks, SE. Bob Dole.
Just watch out for the tricks they try to pull. Watch out for the thoughts they try to get you to put inside your head and then think to yourself, oh, that makes sense, when really it doesn't make sense. With things like the triangle and how you can get more than 180 degrees out of the triangle. Well, that's a trick. They take it from 2 dimensions into 3 dimensions, and then they try to make you think that, oh, actually that makes sense. You draw the triangle on the sphere, and then you shift your perspective, and suddenly it has more than 180 degrees. Well, then you don't have a triangle anymore. So keep an eye out. Watch out. Be on the watch. Pay attention to when they're trying to trick you into thinking that something makes sense when it literally does not make sense. It doesn't stand up to sense.
Good suggestion, Bob. Thank you. All right, I'll be back, guys. Thanks again. All right. Thanks to everybody. Thanks to a special thank you to those channel members. We do have a number of channel members. I'll have to read up their name. I always forget to do that. But you know who you are. Thank you very much. And to those that financially supported the show tonight, that helps me justify spending time away from my family. So I appreciate that. And thanks to everybody in the chat. Seemed like it was a good night in chat. So keep doing what you guys are doing in there. And let's try to keep it positive. Keep the discussion open. We don't want an echo chamber, but we do want civility. So civility is a good thing to have. Even if we disagree with each other vehemently, we can have respect for one another, etc., etc. I don't think there's any reason to attack people personally that we don't agree with. Although I have been known to do it from time to time. We should all make an effort to be a little more civil. So thanks, guys. Appreciate it. We'll see you tomorrow night. I don't know what's going on, but we'll probably have something to talk about. Until then, have a good night.